Hello there and welcome back to the Sleep Science. You find yourself floating in a place that is both vast and strangely quiet. The black canvas of space stitched with pinpricks of cold light. Each star hums like a lighthouse in the distance, each glow hiding dozens, maybe hundreds, of planets you will never step on. The air around you is thin imagination, but the silence is real enough to make your ears ache. You feel tiny, almost laughably small, a speck considering specks. And somewhere out here, Earth is supposed to be the miracle. Yet tonight you're going to wonder whether it's just one survivor in a universe full of failed attempts. You probably won't survive this line of thinking either, at least not without a little dizziness. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're listening from under the covers, or maybe sneaking this while waiting for a late train, let me know your location and your local time in the comments. It's oddly comforting to imagine all of us drifting together in different corners of the world. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You hover over the notion of the cosmic lottery. The idea is simple enough. Trillions of worlds are out there, orbiting stars of every size and shade. Most of them, probably dead ends. A few may host bubbling oceans or thin stretches of atmosphere, but fewer still sustain anything resembling life. Earth won, not because it was destined to, but because chance, physics, and time aligned in just the right way. Think of it as buying a single scratch-off ticket at the Galactic Corner Store and somehow hitting the jackpot. The odds are absurd. To put that in perspective, scientists estimate there could be as many as 100 billion planets in our galaxy alone. That's one Milky Way, one spinning wheel of stars. Multiply that across the observable universe, hundreds of billions of galaxies, and you end up with a number so bloated it feels fictional. Yet, within that immense sample size, we only know of one world that developed grocery stores, cat memes, and the ability to record sleepy science documentaries. Your home, that's it. Historians of science still argue whether we should even frame this in terms of luck. Some lean on the anthropic principle. Basically, you're only able to ask the question because you happen to be in a universe where life worked out. Others push back, suggesting that life may be far more common than we assume. And we're just not clever enough yet to recognize its varied disguises. But still, when you look at the fraction of planets we've actually checked, the ratio of possible abodes versus confirmed successes, you start to see Earth as less a certainty and more a fluke. You drift back in time, picturing a swirling disk of gas and dust about 4.6 billion years ago. The solar system wasn't so much a carefully arranged family portrait as it was a demolition derby waiting to happen. Rocks slammed into rocks. Whole embryonic planets got smashed apart before they could cool. One of those colossal collisions is believed to have gouged out the debris that would eventually become the moon. So yes, technically you live on the aftermath of planetary carnage. The Earth you know today is already the second or third draft. A lot of rough copies were crumpled up and tossed into the stellar recycling bin before one version stuck. Here's the quirky tidbit of the night. Some ancient Greek philosophers speculated about the existence of other worlds as early as the 5th century BCE. Democritus, the same thinker who first played with the concept of atoms, imagined infinite worlds both larger and smaller than ours, many of them barren, others brimming with unknown life. He didn't have a telescope, only a restless mind, but in a way, he was already thinking about the cosmic lottery. Of course, Aristotle ruined the fun later by declaring Earth the centre of everything, which, let's be honest, feels a little like your friend hogging the aux cord and insisting their playlist is the only valid one. Now picture yourself strolling through a metaphorical casino the size of the universe. Each slot machine is a star, and each pull of the lever spins up a new planet. Most of the results? Bust. A frozen wasteland here. A boiling lava ball there, a gaseous giant with no surface at all. But every now and then 3 cherries line up. Stable orbit, protective atmosphere, liquid water, ding ding ding. Life has a shot. The absurdity is that out of trillions, Earth just happened to land the combo early enough and stably enough to let things crawl from chemistry into biology, from slime into sentience. As you wander deeper into this casino imagery, you can almost hear the clamour of failed worlds. The slot machines don't cheer, they cough, they hiss, they sputter. You picture Venus spitting toxic clouds instead of prizes, Mars flashing a watery jackpot long ago, only to snatch it back with thin, choking air. Somewhere else, a rogue planet tumbles across the floor, the equivalent of a slot machine torn from the wall and rolled into the parking lot. Not a friendly place to rest your head. Yet, this casino's rigged in another way. You only notice the machine you're standing at. You're here because Earth worked. You don't wake up on a failed world because you wouldn't be awake at all. The silence of the others is deafening precisely because you're not there to hear their static. You let this thought lull you, slipping into that blend of awe and unease. The scale is so ridiculous that it makes your own anxieties seem quaint. Worried about tomorrow's meeting. Somewhere, a planet just evaporated into its star. Feeling guilty for forgetting to water your houseplant? Mars forgot how to water itself for billions of years. You're doing fine. A little sarcasm sneaks in here. If Earth really is the winning ticket, then congratulations, you're the grand prize, redeemable for one lifetime of questionable Wi-Fi and student loans. Not exactly the golden yacht you imagined, but still, given the alternatives, lava oceans, ammonia skiers, eternal night, you probably got the better deal. Let your thoughts drift again, further outward. Picture all those failed worlds as part of a hidden archive, volumes stacked endlessly on the shelves of the universe's library. Each book begins the same way. In the beginning, dust gathered, but most stories end by page 3, the ink smeared by heat, cold or vacuum. Earth's volume is one of the few that carried on, scribbling chapters through dinosaurs, ice ages, and you sitting here now, historians still argue whether the library is mostly tragedy or comedy, but you know better than to expect a neat label. And here comes another quirky morsel. In 1995, when the first confirmed exoplanet around a sun-like star was discovered, astronomers named it 51 Pegasi b. The planet turned out to be a gas giant orbiting ridiculously close to its star, so fast it whipped around in just 4 Earth days. Imagine trying to hold on to your coffee mug in that world, but the real kicker, that discovery shattered the neat, Earth-centered models of planetary systems. Suddenly the cosmic casino felt wilder, more unpredictable, jackpots of every shape, some unthinkably strange. The universe, it seems, isn't shy about running experiment after experiment, might wither instantly, some hang on too long in inhospitable silence. A rare few strike balance, and you just happen to be perched on one of the lucky few. That thought should keep you awake, but strangely it makes your eyelids heavy, as if the weight of billions of failures tucks you deeper into your mattress. As you hover here, suspended between awe and drowsiness, consider the smallness of your breath against the enormity of the void. You inhale, and the oxygen you pull into your lungs is the product of photosynthesis, a planetary trick invented by humble microbes. Without them, Earth might have joined the gallery of failed worlds, another half-finished story. Instead, you exhale carbon dioxide into a room that probably smells faintly of laundry detergent or the ghost of dinner. That little detail alone separates you from a trillion lifeless rocks spinning pointlessly in the dark. Maybe Earth isn't the ultimate prize, not the most dazzling slot machine in the galactic casino. Maybe it's just one of the few that didn't break down immediately. Either way, you ended up here, awake enough to wonder, tired enough to let the thought dissolve. And as you begin this journey through failed worlds and fragile survivors, you hold on to one truth. If existence is a lottery, then you've already won the only ticket that matters. You sink deeper into the quiet of space, drifting backward in time again, until the stars around you fade into a cloud of dust and raw fire. Planets aren't born as blue and green jewels, they begin as chaos. Picture a newborn rocky world, not solid ground, not forests or beaches, just a rolling ocean of molten stone glowing bright enough to burn your eyes shut. The surface is liquid rock, restless waves of lava surging like tides. Mountains rising only to collapse back into their own heat. No place for a stroll unless you enjoy walking shoes with a melting point above 2000 degrees Celsius. You hover above such a world and the air, if you can call it air, is thick with steam and choking gases. Volcanoes aren't isolated mountains here. The entire planet is one endless eruption, tantrum of gravity and chemistry trying to settle into something stable. Occasionally, huge chunks of rock the size of cities crash down from space, leftovers of planetary construction slamming into the surface with enough force to fling oceans of magma skyward. For a moment, the entire horizon glows white-hot, brighter than lightning. The planet doesn't flinch. This is normal childhood in the solar system. Historians still argue whether Earth's earliest surface cooled quickly or stayed molten for tens of millions of years. The evidence hides under layers of rock long since recycled by plate tectonics, so the debate is a bit like trying to reconstruct a toddler's first tantrum based on the scribbles they made in kindergarten. But one thing is clear: if you had visited Earth in its opening act, you'd find no place to land, no atmosphere to breathe, and no mercy for anything fragile enough to be called life. Here's the quirky tidbit for this stretch. Some geologists jokingly call this era of planetary development the Hadean, after Hades, the Greek underworld. It's a polite academic way of saying, yeah, this place was basically hell. And honestly, if hell had loyalty cards, early Earth would have earned platinum status. Imagine rivers of lava cascading into lakes of lava, and storms of rock fragments falling from the sky. The phrase bad weather doesn't quite cut it. You wander now toward another young world, not Earth this time, but a generic rocky planet forming around a distant star. Its skin is still molten, but you notice something fascinating. As the surface slowly cools, a thin crust begins to form, floating like cracked ice on a glowing lake. The crust is fragile, easily punctured by fresh impacts, but it represents the first hint of structure, a pause button in the chaos. Beneath, the mantle churns like soup on a hot stove, convection currents dragging molten rock in vast, slow circles. Every now and then, pressure builds until the surface fractures, releasing fountains of fire that reach into the newborn sky. You can almost hear the hiss. Scientists think this is how rocky planets begin. Accretion, collision, melting, cooling, repeating. Gravity is the artist, pulling the matter into a ball, squeezing it until the interior heats enough to stay alive with motion for billions of years. Without that heat, the world would be dead before it began. With too much, it risks becoming a permanent inferno. Finding the balance is rare. The cosmic lottery wheel keeps spinning. You imagine standing, hovering above the magma oceans. There's no smell you'd recognize, but the air brims with carbon dioxide, nitrogen, maybe some ammonia, all swirling into a primitive atmosphere. It would feel heavy, suffocating, pressing on your chest until you collapsed. Yet this cocktail of gases is the start of something essential. Without those first outgas vapors, there would be no blanket to trap warmth, no chemistry waiting for water. It's strange comfort. Even poisoned skies have purpose. Back to Earth for a moment. Roughly 4.4 billion years ago, scientists believe a colossal impact changed everything. A Mars-sized body slammed into the proto-Earth, tearing off chunks that later coalesced into the Moon. You hover above this event like an unimpressed tourist watching a slow-motion explosion. The planet glows, its surface reliquefied, and the new satellite slowly takes shape. Without that impact, Earth might not have gained the tilt that gives you seasons. Without the Moon's stabilizing pull, the planet could have wobbled chaotically, never settling into a climate fit for life. One catastrophic collision ironically saved the day, proof that even violence can leave behind gifts. And here's where your gentle sarcasm slides in. If someone tried to sell you vacation packages to the early Earth, they'd have to market it as an extreme spa. Enjoy full-body exfoliation from volcanic ash. Soothe your lungs with ammonia aromatherapy. Experience the cleansing power of lava waves. Not exactly a 5-star resort unless your definition of luxury is being incinerated on arrival. As you float onward, you picture other solar systems where the script plays differently. Some planets never cool enough, remaining volcanic nightmares forever. Others cool too quickly, locking up their interiors and losing the heat needed to drive tectonics. Historians of science still argue whether tectonic activity is essential for long-term habitability. Without it, the recycling of carbon, water and nutrients might stall, leaving the surface sterile. With too much, the crust could fracture endlessly, preventing stable continents from forming. Earth again seems like the unlikely sweet spot, just messy enough to stay alive, not messy enough to self-destruct. Let your senses sink deeper. Imagine the soundscape. Constant thunders as meteors crash, the hiss of lava cooling, the deep groans of the crust shifting. Imagine the visuals. Skies glowing orange from volcanic dust, lightning and lashing down into sulphurous clouds. You might even feel the ground tremble beneath you as the planet contracts and stretches. There's no life here yet, but it already feels alive. The chaos itself hums with potential. And then, unexpectedly, a softer vision enters your mind: raindrops. Scientists propose that at some point, as Earth cooled, steam condensed and fell for millions of years, filling the first oceans. Imagine rain that never stops, not drizzle but sheets of water hammering molten rock into steam. Lakes form, merge and expand until the surface is dotted with basins of liquid. For the first time that you can almost recognize something Earth-like, though the seas are acidic, boiling and unfriendly. Still they are water, and water changes everything. Here's a quirky fact to tuck under your pillow. Tiny crystals of zircon found in ancient rocks suggest that liquid water may have existed on Earth as early as 4.3 billion years ago, far sooner than scientists once thought possible. These zircons are like little postcards from a past otherwise erased, whispering that even amidst hellfire, calm pools may have glimmered under a hostile sky. If true, it means the seeds of habitability sprouted in the unlikeliest of places, a reminder that life's tenacity often outpaces your imagination. Pause now, breathe. You're drifting above a planet no longer just magma, but something halfway to recognizable. You feel both wonder and exhaustion, as though you've just watched the world endure its toddler tantrum. The chaos is starting to settle. The casino's slot machine hasn't landed cherries yet, but the reels are slowing, and for the first time you can imagine it might. Sarcasm tucks itself in once more. If the universe truly is full of failed worlds, then maybe the early Earth was just a procrastinator that accidentally succeeded. Sure, I'll cool down eventually, maybe grow some oceans, let life have a go. Just give me 1 billion years and a moon. Cosmic laziness somehow turned into brilliance. You find yourself hovering heavy-lidded, lulled by the contradiction. That survival depends on chaos, that hell gives rise to oceans, that failure shapes the path to success. The molten starts of rocky worlds are both terrifying and oddly comforting, reminders that beginnings rarely look like endings, and that even the most hostile starts may hide future possibilities. As your eyes close, you leave behind the glowing surfaces and choking skies. You carry with you the image of Earth as it was, a glowing ember in the dark, furious and fragile, still spinning, still cooling, still preparing for everything to come. You drift across the solar system, coasting through velvet dark until a pale yellow glow rises before you. At first it looks inviting, soft and golden, like a hazy lantern hanging near Earth's orbit. But as you draw closer, you realize the glow is a mask, a dangerous one. This is Venus, Earth's so-called twin, a planet nearly the same size, made from the same raw ingredients, born in the same fiery nursery. And yet it's a nightmare in disguise, proof that siblings can grow into very different adults. You hover above the cloud tops, their beautiful, smooth, creamy swirls curling like whipped milk in coffee. But the clouds are not soft mist. They're sulfuric acid droplets sharp enough to shred metal and melt skin. The sky glows with sunlight scattered and trapped, like a giant greenhouse with no vents. From this height, you might imagine gliding in a balloon, but lower down the air presses so hard it would crush you in seconds. 90 times Earth's pressure at the surface, like standing a kilometre underwater with no submarine. Historians of science still argue whether Venus might once have been habitable. Some suggest early oceans shimmered across its surface billions of years ago, feeding a climate not unlike Earth's. Others counter that Venus was doomed from the start, too close to the sun, too bathed in heat, too vulnerable to runaway greenhouse warming. The evidence is blurred by time and geology. Venus hides her past well, her crust constantly reshaped by volcanic floods that erase ancient scars. You're left squinting at a puzzle missing most of its pieces. Quirky tidbit for tonight. In the 17th century, Galileo pointed his telescope at Venus and realized it went through phases like the moon, crescent, half, full. That little detail toppled the old Earth-centered model of the universe. If Venus orbited Earth, it couldn't possibly show those phases. Instead, it circled the sun, a revelation that literally changed humanity's place in the cosmos. Imagine that, one cloudy ball of poison accidentally proving Earth wasn't the center of everything. Not bad for a planet that would cook you alive in under a minute. Now you dip lower, into the thick atmosphere. The descent feels like sinking into soup, the clouds hugging tighter with every kilometre. The heat intensifies until it climbs past 400 degrees Celsius, hot enough to melt lead. The air is mostly carbon dioxide mixed with nitrogen, layered so densely that sunlight struggles to filter down. The surface, when it finally reveals itself, is not soft sand or grassy plains. It's baked plains of rock, shattered mountains, endless volcanic fields. The horizon glows orange or distorted like a mirage. You can't see far, the air bends light like water in a glass. Walking here would feel like a cruel prank. Each step a stumble in lead-melting heat, each breath impossible without a pressure suit thicker than your own body. Even metal probes sent by human hands barely last 2 hours before collapsing, electronics fried, hulls crushed. You imagine yourself as one of those probes, your sensors dimming, your lenses fogging until silence swallows you. Venus tolerates no visitors, and here's where the sarcasm slides in. If real estate agents sold planetary homes, Venus would come with a spectacular sales pitch. Gorgeous panoramic views, rich volcanic soil, only a short hop from Earth, comes with complimentary acid rain and a cozy climate that doubles as a pizza oven. Hard pass, but Venus isn't just a cautionary tale, it's a mirror. It shows you what happens when the greenhouse effect spins out of control, and on Earth, greenhouse gases keep you warm enough to avoid being an ice ball. On Venus, carbon dioxide built a trap with no escape. Sunlight poured in, heat bounced off the surface, and instead of radiating into space, it stayed locked beneath the clouds. Over millions of years, temperatures rose, oceans, if they ever existed, boiled away, water vapor joined the atmosphere, and the cycle fed itself. More heat, more vapor, more carbon dioxide. A planetary death spiral. Scientists still argue how fast this transformation happened. Was it a slow simmer that lasted billions of years, or a sudden tipping point that changed the planet forever? Either way, the result is the same. A landscape where survival is not only unlikely, but unthinkable. Your senses wander across the surface. You drift past Maxwell Montes, a mountain range taller than Everest. You skim over vast plains covered in hardened lava, called pancake domes, because of their strange flattened shape. Some scientists believe Venus still has active volcanoes, belching sulfur into the skies, renewing its poisonous veil. If true, it means the planet isn't just dead, it's alive in a hostile way, a constant eruption with no outlet for calm. And yet strangely, there are whispers of possibility. Some researchers wonder if high in the clouds, 40 or 50 kilometers above the inferno, conditions might be gentler. Temperatures there hover closer to human comfort, pressures similar to Earth's sea level. Could microbes float in those upper layers, living off sulfur and sunlight? It sounds wild, but Earth's microbes thrive in acid pools, in nuclear reactors, even in clouds. Maybe Venus still harbours a hidden biosphere, drifting in its toxic skies like invisible balloons. You don't know. Nobody does. But the idea hovers like a fragile hope. Quirky story break. In the 1980s, the Soviet Union sent the Venera landers to Venus. These probes were the first, and so far the only, to snap photographs from the surface. The pictures showed cracked rocks under a dim orange sky, like the inside of an oven. The landers worked briefly, then succumbed to the heat. One even recorded the sound of Venus's winds before falling silent. You can imagine the lonely little machine, whispering across space for a final moment before being swallowed by silence. It's almost poetic, like a message in a bottle tossed into an endless sea. You float back into the higher atmosphere, retreating from the crushing pressure, letting the temperature ease. Looking down, you feel both awe and dread. Venus is Earth's reminder that being almost right is the same as being completely wrong. Just a little too close to the sun, just a little too much carbon dioxide, and paradise became prison. It's like watching a sibling make every wrong life choice and realizing how narrowly you avoided the same fate. Sarcasm makes another cameo. If Earth and the Venus really are twins, then Earth is the responsible sibling with a steady job, and Venus is the one who joined a pyramid scheme, burned out, and now lives in a haze of bad decisions. Same DNA, very different outcomes. And as you linger, eyelids heavy, you realize the cautionary part isn't just about planets, it's about fragility. Earth's balance is not guaranteed. Change a few variables, distance from the sun, composition of the air, volcanic output, and your world could tip into the same spiral. Venus is a burned reminder carved into the sky, a billboard of don't let this happen to you. Still, the thought doesn't need to be frightening. Instead, it's oddly calming. Because if Earth can avoid Venus's mistakes for billions of years, it proves survival is possible. It shows that fragile balances can hold, that chaos can stabilize. You let the image soften in your mind. Venus glowing golden in the twilight, beautiful and deadly. A cosmic lighthouse warning travelers to steer clear. Your thoughts slow as you drift away from the sulfur clouds. You carry the lesson with you. Not all twins survive, not all chances pay off, but sometimes knowing the failures is what helps you treasure the rare success. Earth is one coin toss away from being Venus, but it isn't. You're here, breathing air not acid, under skies not boiling, listening instead of melting. That improbability alone is enough to ease you further towards sleep. You push off from Venus's suffocating clouds, your body eager for distance, and drift outward through the velvet dark. The sun shrinks a little, its light less punishing, and ahead you see a smaller world glowing red like a dying ember. This is Mars, the almost home, the desert neighbour that tempts human imagination with the promise of what if. From afar it looks gentle, a dusty rose marble in orbit. Up close the truth is harsher, yet compared to Venus's inferno, Mars feels like a halfway house, a planet that almost made it but tripped on the finish line. You hover above its atmosphere, which is barely there at all. A whisper of carbon dioxide clings to the planet, too thin to trap much heat, too weak to protect from cosmic radiation. At night, temperatures plunge so low your breath would freeze inside a helmet. By day, dust storms whip across plains and can swell into tempests that cover the entire globe. Imagine a sandblaster operating for months on end, except the sand is fine red powder that seeps into everything. NASA engineers joke that any future astronaut mission to Mars will need a dust department just to cope with the endless grit. Your spacesuit would creak like an old hinge within days. Historians of science still argue whether Mars was once blue. Ancient river valleys, dry deltas, and minerals that only form in water all whisper the same story. Billions of years ago, Mars had lakes, maybe even oceans. Some scientists believe it might have boasted a climate not unlike Earth's, with rainfall and running rivers shaping its surface. Others argue the evidence suggests a colder, icier past, with water mostly locked under glaciers. The debate continues, and Mars keeps her secrets beneath layers of rock and dust. Here's your quirky tidbit. In 1877, an Italian astronomer named Giovanni Schiaparelli drew maps of Mars and labelled the dark streaks he saw canali, meaning channels. English speakers misread this as canals and promptly decided that intelligent Martians must have built them. For decades, people imagined a dying race digging waterways to preserve their civilization. It was a beautiful mistake, and it inspired generations of science fiction, from H.G. Wells's warlike Martians to Ray Bradbury's poetic ones. All from one mistranslated word. You can thank that slip for much of humanity's fascination with the red planet. Now, picture yourself standing on the Martian surface. The sky is not blue but a muted butterscotch, tinted by dust suspended in the thin air. The horizon feels closer than Earth's, curved more sharply, as if the world itself is smaller under your feet. Mountains tower impossibly high. Olympus Mons, the largest volcano in the solar system, 3 times taller than Everest. Canyons stretch so vast they could swallow whole countries, Valles Marineris, a scar that runs for thousands of kilometers, deep enough to make the Grand Canyon look like a sidewalk crack. Everywhere you look, the planet screams scale, and yet it is silent, utterly still, save for the occasional whisper of wind. Life here would not come easy. Without a thick atmosphere, radiation from the sun and cosmic rays rain down unhindered. Without a strong magnetic field, the surface is unshielded, naked to space. Even if you found water, frozen under the soil or seeping as briny trickles, you'd struggle to keep it liquid. It evaporates or freezes almost instantly. Mars is like a house stripped of insulation and roof, beautiful from outside but unlivable inside. And yet Mars is the dream. You can almost hear the hum of future rockets landing, habitats inflating, greenhouses sprouting in domes. Humans have always looked at Mars not as a failure, but as a second chance waiting to happen. Sarcasm sneaks in here. We're basically that friend who sees a derelict shack and says, "Oh, with a little paint and some elbow grease, this could be our summer home." Sure, if you bring along $1 billion and a nuclear reactor or 2. Still, Mars seduces because it is almost there. Unlike Venus, it's not too hot. Unlike Jupiter, it's not all gas. Unlike Mercury, it's not too close to the Sun. It is tantalizingly near to being livable. Some scientists speculate that billions of years ago, Mars may have harbored microbial life, If so, it could still exist underground today, clinging to warmth near volcanic vents or buried aquifers. Imagine tiny cells hidden beneath your boots, survivors of an ancient era, waiting patiently for discovery. The thought makes your pulse slow. You picture Mars not as a failure but as a missed opportunity, a place where life nearly flourished but stumbled. Historians still argue what tipped the balance. Did Mars lose its magnetic field too soon, stripping its atmosphere? Did volcanic activity die off before it could replenish greenhouse gases? Did the planet's small size doom it from the start, its heat escaping too quickly? The answers remain tangled in red dust. Quirky break again. In the 1970s, NASA's Viking landers performed the first direct life detection experiments on Mars. One test seemed to show signs of microbial metabolism in the soil, but later results contradicted it, and the scientific community remains divided even today. Some insist the signal was a hint of life, others call it a false positive caused by unusual chemistry. Decades later, the debate still simmers, unresolved. You can almost picture the Martian microbes laughing quietly underground. Nice try, humans, almost caught us. You stroll mentally through the idea of colonization. Imagine sleeping in a pressurized habitat while outside the temperature hovers at -80. Imagine farming potatoes in red dirt laced with toxic perch laurets, or drinking water mined from icy soil. Every resource would be a battle, every breath a gift of technology, and yet, you know humanity will try. Because humans have a habit of walking toward deserts with suitcases, convinced they can make it work. Mars is also a mirror in another way. It shows what happens when a world is too small to hold on to its life. Earth, bigger and luckier, kept its molten core churning, its magnetic field humming, its atmosphere intact. Mars, smaller, cooled too fast, lost its shield, and slowly withered. It is like watching an older sibling grow frail, teaching you how fragile health can be. You realise Earth's habitability is not just about distance from the sun, it's about magnetism, timing, another lottery win. Your sarcasm perks again. If Mars really is humanity's plan B, then it's the kind of backup plan where your spare tire is flat, the car manual is in Latin, and the nearest gas station is 56 million kilometres away. Not exactly confidence boosting, but at least it's there, a distant possibility. And still, Mars hums with allure. The rovers crawling across its plains are like toy cars left by children, each one whispering data back home. Spirit and Opportunity trudged for years. Perseverance now drills into rocks searching for fossils of microbes that may have lived billions of years ago. Each discovery feels like a breadcrumb in a story you desperately want to finish. Because if Mars was almost alive once, it proves the universe doesn't hand out habitability to Earth alone. The stillness here settles into you. You imagine lying back on the red dust, the thin sky glowing faint pink. 2 tiny moons, Phobos and Deimos, hanging overhead like irregular pebbles. The silence is profound, a silence no Earth desert could match, and it seeps into you, calming your thoughts, quieting the chatter of the day. Almost home, almost alive, Mars feels like a lullaby of what could have been. You drift higher again, leaving the red plains below. You look down one last time and see Mars for what it is. Not failure, not success, but a story half written. A reminder that near misses are still lessons, and that sometimes survival is measured in almosts. Earth avoided Mars's fate, but not by much, and that thin margin between too small and just right, between almost home and home, is what lets you close your eyes tonight. You leave Mars behind, brushing the red dust from your thoughts, and drift farther outward. The sun shrinks again, its warmth fading, and before long you enter the realm of the giants. They loom like titans in the dark, swollen spheres of swirling gas, each one so vast it could swallow Earth whole 1,000 times over. Their clouds twist in colours that look painted by careless gods, Jupiter's violent oranges, Saturn's buttery creams, Neptune's royal blues. Beautiful from afar, lethal up close, these are the gas giant graveyards, planets too massive, too storm-ridden, too alien for life as you know it. Hover over Jupiter first, the king of the solar system. Its striped bands churn like conveyor belts of cloud, winds roaring at hundreds of kilometers per hour. Below them, no solid ground, no place to stand, just endless layers of gas compressing into liquid under crushing pressure. If you tried to land, you'd descend endlessly until your craft collapsed like a soda can under a steamroller. Even the famous Great Red Spot, a storm larger than Earth, has raged for centuries, a permanent hurricane in a sky with no calm. Imagine trying to set up a lawn chair there. Not great. Historians of astronomy still argue whether Jupiter is a failed star. It's made mostly of hydrogen and helium just like the Sun, but it never gathered enough mass to ignite fusion. Some scientists half-jokingly call it a stunted star, a flickering match that never caught flame. If Jupiter had been even 80 times more massive, you'd have 2 suns instead of 1, and Earth, baked under twin fire, might never have grown forests or oceans. Quirky tidbit. When Galileo first turned his telescope on Jupiter in 1610, he saw 4 little dots dancing around it. At first, he thought they were stars, but then he realised they orbited the planet. Today we call them the Galilean moons, Io, Europa, Ganymede, and Callisto. This discovery shocked the world. It proved not everything revolved around Earth. And in a poetic twist, those moons may harbour more liquid water than Earth itself, locked beneath ice or boiling under volcanic fury. Even graveyards hide treasures. Now you drift past Saturn, its rings stretching like delicate jewellery across the dark. From afar they look solid, like grooves carved in a record, but up close they're billions of chunks of ice and rock whirling in orbit. Saturn itself is a pale giant, its atmosphere gentle-looking compared to Jupiter's, but no less inhospitable. Beneath the pastel clouds lies the same deadly truth. No solid surface, just endless gases tightening into crushing pressure. If you stepped out of a ship here, you wouldn't land, you'd sink, fall forever until you were squeezed into oblivion. A planet that swallows visitors whole. And sarcasm whispers, imagine the travel brochure. Come to Saturn, admire the stunning rings, enjoy an eternal freefall into oblivion, and don't worry about ever hitting bottom. Perfect for thrill seekers with no return ticket. Move farther still and Neptune greets you with its cobalt blues, winds tearing across the planet at speeds faster than the sound of a jet. Uranus tilts on its side, rolling around the sun like a cosmic barrel, its seasons lasting decades. Both giants are icy in their upper layers, but below them, under pressure so fierce it bends chemistry itself, water and methane might form exotic states of matter, superionic ices and even rainstorms of diamonds. Imagine standing in a storm where gemstones fall like hail and realize you could never live to enjoy it. Beauty and death braided together. Scientists wonder if these giants are the guardians of Earth or its silent threats. Their gravity acts like a shield, flinging away comets that might otherwise smash into your planet. At the same time, they can also redirect dangerous rocks inward, aiming them like cosmic slingshots. Historians of science still argue which role dominates. Are Jupiter and Saturn your protectors or your assassins? Perhaps both. But what makes them graveyards isn't only their hostility. It's their habit of collecting moons, each a tiny world orbiting a giant that cannot host life itself. Dozens, sometimes hundreds, each circling endlessly like mourners at a funeral. Some of those moons, like Europa and Enceladus, may hide oceans beneath their icy crusts. They are whispers of possibility orbiting monsters of impossibility. The irony is sharp. Life may someday be found not on the planets themselves, but in the shadows they cast. Pause a moment and let the scale sink in. Jupiter's mass is more than twice that of all the other planets combined. Saturn's rings could stretch from Earth to the Moon if unrolled flat. Neptune is so distant that a year there lasts 1/65 Earth years. These giants are enormous markers in the solar system, so dominant that they shape everything around them. And yet, despite all their grandeur, they are sterile. Too much gravity, too much gas, too little stability for fragile chemistry to build a foothold. They are monuments to might without life. Here's a quirky story. When Voyager 2 flew past Neptune in 1989, it discovered the planet's great dark spot, a massive storm swirling in its atmosphere. But when the Hubble telescope looked years later, the storm was gone, replaced by new ones in different spots. It's like watching clouds on Earth, but scaled up to the size of continents. Weather here isn't gentle, it's a planet's whole personality changing overnight. Imagine writing tomorrow's forecast for Neptune. Expect screaming winds, possible diamond and showers, and a new hurricane the size of Africa. The thought presses into you, heavy and strange. So many giants, so little chance. You realise life as you know it cannot take root here, no matter how colourful the clouds or how dazzling the rings. And yet without them, Earth's story might never have unfolded. Jupiter's gravity prevented the asteroid belt from coalescing into another planet. Saturn's pull may have steadied the system's architecture. The graveyards are also gardeners, shaping the conditions that allowed one small rocky world to thrive. Sarcasm stretches its legs again. Earth basically owes its existence to a bunch of oversized gas bags. Without them, maybe no moonlit beaches, no rainy afternoons, no midnight snacks, just another failed world drifting unseen. It's humbling to know that your planet's success depended on neighbours you could never visit. Now you hover, letting the silence of these giants soak in. They're loud in appearance but quiet in meaning, hulking presences with no voice of their own. They spin endlessly, their storms raging, their rings glittering, but to no audience, no birds, no oceans, no civilizations, just storms applauding themselves in an empty theatre. As you turn away, eyelids heavy, you feel both awe and relief. Awe at their scale, relief that Earth was not built this way, too small to be a giant, too large to be lost like Mars, too far to be cooked like Venus, just balanced enough. The gas giants remind you that power isn't everything. Sometimes survival belongs not to the biggest, but to the balanced. You drift outward one last time, glancing back. The giants gleam in the dark, graveyards of failed potential, guardians of fragile possibility. Their storms roar on without audience, their beauty unseen by any eye but yours tonight. And you let that image soften, like a lullaby painted in clouds, as your breath slows and your body sinks deeper into calm. You peel away from the gas giants themselves, leaving behind their endless storms and heavy silence, and turn instead to their attendants, the moons. If the giants are graveyards, then their moons are like hidden gardens, little pockets of possibility orbiting hulks too hostile for life. They come in every shape and size, icy spheres cracked like eggshells, volcanic fireballs spitting sulfur, cratered rocks with surfaces as old as time. You drift toward them, almost forgetting the giants they orbit, because these moons carry whispers of life in places you least expect. First, you skim above Europa, one of Jupiter's Galilean moons. From a distance it gleams smooth and white, like a pearl floating in the dark. But up close, its surface is streaked with brown and red lines, crisscrossing like veins or cracks in glass. These are fractures in the ice crust, some stretching for hundreds of kilometres. Beneath that ice, scientists are nearly certain, lies an ocean deeper than Earth's, kept liquid by the tidal pull of Jupiter's gravity. Imagine standing on frozen ground while just a few kilometres below, entire seas churn in the dark, warmed by friction, waiting quietly for eons. Historians still argue whether Europa's ocean could truly support life. Some say yes, the conditions are similar to Earth's deep-sea vents, where bizarre creatures thrive without sunlight. Others caution that Europa may lack the chemical ingredients life requires, or that the ice may be too thick to allow exchanges between the ocean and the surface. The debate lingers, unresolved, like a question mark carved into the ice itself. Here's your quirky tidbit. In Arthur C. Clarke's novel 2010, Odyssey 2, a message to humanity warns, "All these worlds are yours, except Europa. Attempt no landing there." The line has stuck in popular imagination, giving Europa an almost sacred aura, as though the moon itself is off limits. In reality, it's not hostile in that sense, it's just profoundly mysterious, too beautiful and too important to risk contaminating with Earth's germs. You drift now toward Ganymede, the largest moon in the solar system. Even bigger than Mercury. It has its own magnetic field, the only moon known to have one, and its icy crust may also cover a hidden ocean. Imagine the irony, this moon is larger than a planet, yet it spends its life orbiting another world. You float across its ridges and grooves, vast geological scars that tell of ancient tectonic movements. Ganymede is like a library of frozen history, its surface etched with chapters of ice and rock. Then there is Callisto, another Galilean moon, its surface battered by impacts. Unlike Europa's smoothness or Ganymede's strange terrain, Callisto looks old, scarred, tired. Yet beneath its crust, scientists suspect another salty ocean might exist. 3 moons of Jupiter alone could hide more water than Earth, tucked away in icy coffins. Imagine that. Oceans everywhere, none visible, all concealed beneath white masks. It makes you realise that desert worlds in space may not be so dry after all. Sarcasm trickles in. If water really is the elixir of life, the solar system is basically a cosmic hoarder. Earth shows off its oceans like fine china, while moons like Europa and Enceladus shove theirs into the attic and pretend nothing's there. Oh, these old things. Just a few hidden seas under ice, no big deal. Now you swing towards Saturn's domain, to Enceladus. It's small, barely 500 kilometers across, tiny compared to Ganymede, but it makes up for its size with drama. Its surface is bright and shiny, reflecting sunlight like fresh snow. But the real show is at its south pole, where cracks called tiger stripes spurt geysers of water vapor and ice into space. You can actually see the plumes erupting, fountains miles high, spraying material that forms part of Saturn's E-ring. Beneath Enceladus's ice, again, lies a global ocean, and here, scientists have detected organic molecules in the plumes, compounds that hint at chemistry friendly to life. Imagine drifting through those geysers, droplets pattering against your visor, knowing they were launched from an ocean you'll never see. It feels like brushing fingertips with something alive, though you can't prove it. Some researchers dream of sending probes to dive through the plumes, tasting them for signs of microbes. It would be one of the easiest chances in the solar system to check for life. But so far, Enceladus remains just a promise. Next stop, Titan, Saturn's largest moon, and one of the strangest bodies in the solar system. Unlike the others, Titan has a thick atmosphere, so dense it feels more like a planet than a moon. Orange haze covers everything, a permanent twilight sky. If you land, the air is cold, minus 180 degrees Celsius, but the landscape is astonishing. Lakes and rivers cut across the surface, not of water, but of liquid methane and ethane. Imagine standing on a beach where the waves are made of natural gas. Imagine rain falling from clouds, filling dark seas under an alien sky. It's both bizarre and oddly familiar, a mirror world with chemistry swapped. Historians still argue whether Titan could host life based on methane instead of water. On Earth, life is carbon and water-based, but Titan might offer an entirely different playground. Could there be cells built from methane, membranes stable in the cold? No one knows. The debate is fierce, and Titan holds its answers close as if daring you to guess wrong. Here's your quirky tidbit. In 2005, the European Space Agency's Huygens probe parachuted down to Titan's surface, taking pictures during its descent. It revealed river channels carved in the ground, a shoreline where liquids had flowed, and even pebbles rounded by erosion. For a few hours, humanity stood on a world over 1 billion kilometers away. Then the probe went silent, leaving behind a handful of haunting images of an alien beach. You pause now, looking back at all these moons. They orbit giants that cannot host life, yet they themselves may hold the richest possibilities in the solar system. Oceans hidden under ice, geysers erupting into space, rivers of liquid methane, all of it humming with potential. It's like discovering secret gardens around a row of ruined mansions, little sanctuaries that survive despite their monstrous landlords. Sarcasm leans in. If life does turn up in one of these moons, Earth is going to look awkwardly at Jupiter and Saturn, as if to say, "So you were hiding roommates this whole time?" The solar system is full of surprises, and the giants may not be as barren as they seemed, at least not if their children are counted. The stillness of space presses in again, but it feels softer here. You imagine yourself perched on Europa's ice, gazing at Jupiter looming huge in the sky, striped and glowing. You picture floating through Enceladus's geysers, Titan's orange twilight pressing against your helmet, Ganymede's ridges sprawling below. Each moon whispers maybe, and the word is enough to lull you deeper. Historians of science still argue which of these moons should be the first priority for exploration. Some say Europa with its hidden ocean, others insist Titan with its strange methane cycles, still others prefer Enceladus with its convenient geysers. The debate will continue, but the truth is simple. The solar system may hold not one potential world, but many tucked quietly under ice, waiting. You drift back now, pulling away from the moons, carrying their whispers in your thoughts. Fragile worlds of possibility circling lifeless giants, proof that even in graveyards seeds can grow. And as your eyes soften, you realize the lesson is not just cosmic, it's personal. Even when surrounded by storms, you too might carry hidden oceans of potential, waiting quietly until the time is right. You drift farther still, past the familiar family of the solar system, until the sun shrinks to a mere star among countless others. The black around you thickens with possibilities. Every point of light hides planets, worlds you will never walk, surfaces you will never touch. Astronomers have only begun to scratch the surface of this cosmic census. And yet what they've found already reveals a gallery of extremes. Tonight you pause at one particular corner of this vast gallery, the exoplanet deserts, scorched and barren spheres that circle their stars too closely, baked into sterility before they had any chance to bloom. Imagine a planet hugging its star so tightly that its year lasts only a few days. On Earth, you measure time by birthdays and Mondays. Here, a year is over before you've finished unpacking your suitcase. These are hot Jupiters, hot Neptunes, even hot Earths, planets baked by the relentless starlight until their atmospheres puff out, glowing, sometimes even stripped away. Some of them are tidally locked, forever showing one face to their star, one hemisphere scorched to hellfire, while the other freezes in eternal night. You can almost picture yourself standing on the Terminator line, that narrow twilight band between inferno and ice, wondering whether it feels more like survival or purgatory. Historians of astronomy still argue how these planets end up so close to their stars. Did they form there, or were they born farther out and later migrated inward, pulled by gravitational nudges until they found themselves shackled to orbits of doom? The debate remains lively, and each new discovery forces the theories to bend and stretch like overworked gymnasts. Here's a quirky tidbit for your pillow. The very first exoplanets ever confirmed in the early 90s weren't found around a normal star at all, but orbiting a pulsar, a dead star's leftover corpse that spins and flashes radio waves like a cosmic lighthouse. Imagine that, planets circling a stellar grave, bathed not in sunlight but in deadly radiation. Not exactly beachfront property, unless your idea of vacation is lying under a neutron beam. Now picture yourself flying over one of these desert worlds, the star so close and bright it fills half the sky. The ground below shimmers like metal left in a forge, mountains glowing at the edges, rivers of lava tracing scars across the surface. The atmosphere, if one exists, boils upward in waves, bleeding into space like smoke from a fire. Scientists have even detected lava rain on some of these exoplanets, droplets of vaporized rock condensing and falling from the sky, only to re-evaporate before they ever reach the ground. Umbrellas are useless here. You'd need a steel roof and a sense of humour. You move on to another scorched globe, one that orbits so close to its star that its atmosphere trails behind it like a comet's tail. The gases are literally being blown away, ripped into space by stellar winds. It's a planet being erased in real time, dissolving into its parent's fury. You can almost hear it sigh, a long, slow exhale into nothing. And here's where sarcasm sidles in. Humans fantasize about interstellar colonization, about hopping from star to star like galactic Airbnb guests, but then you look at planets like these and realize that most of the listings come with the fine print. Warning, surface temperatures hot enough to vaporize you instantly, no refunds for melted luggage. Suddenly staying home doesn't seem so bad, yet the fascination persists because these desert planets stretch your imagination. Earth feels comfortable because it's familiar, but these worlds remind you how varied the universe can be. On one, the atmosphere may glow with exotic chemicals, painting skies green or violet. On another, molten rock might shimmer under a star as bright as 50 suns. They are inhospitable, yes, but also beautiful. Harsh sculptures carved by physics and time. Scientists have spotted exoplanets in the habitable zone too, places where liquid water might exist. But for every one of those, dozens fall into the desert category. Too close, too hot, too stripped bare. The cosmic lottery machine keeps spinning, and most tickets come out blank. In fact, some astronomers suggest that barren worlds may outnumber habitable ones by a wide margin. If true, then Earth really is not just lucky, but absurdly rare, a lush oasis in a desert universe. Quirky break in 2015, astronomers detected a planet, 55 Cancri E, nicknamed the Diamond Planet. It's thought to have a carbon-rich composition, and under extreme pressures, much of its interior could exist as diamond. Imagine walking across a world where the mountains sparkle with crystalline carbon, where the very bedrock is precious stone, and yet it's so close to its star that the surface is hellishly hot, thousands of degrees. A planet made of jewels, utterly uninhabitable. The universe has a sense of humour, wealth beyond measure, and no one alive to spend it. Historians of science still argue whether life could adapt to conditions we consider deserts. After all, on Earth, microbes thrive in boiling vents, acidic lakes, frozen tundra. Could something cling to existence even in lava rains or on tidally locked twilights? Some optimists say yes, pointing out that life is versatile. Skeptics say no. The extremes on these worlds go far beyond anything earthly biology can endure. The debate is unresolved, but the very act of asking makes you realise how narrow your definition of possible has been. You float now between star systems, passing world after world that glows too bright, too close, too stripped. Each one is a reminder that habitability is rare. You begin to see these desert exoplanets as cautionary landscapes, mirages shimmering in the heat of alien suns. They are postcards from realities where life had no chance to begin. Sarcasm slides back. If Earthlings ever do send explorers here, the marketing department will have its work cut out. Come visit Lava World. Free suntan included, though it might be your last. Our slogan, hotter than Venus, colder than death. You almost want to laugh, except that the truth is sobering. These planets really are cosmic deserts, breathtaking but empty. As you watch them whirl around their stars, you feel a strange calm. Their failures do not diminish Earth's success, they highlight it. You realise that for every green forest you've walked, there are a billion lava plains elsewhere, and for every drop of rain that's ever touched your skin, there are countless worlds where the only rain is rock. The contrast makes your breath slow, your eyes heavier. You close your thoughts on one final vision. A desert exoplanet silhouetted against its star, atmosphere trailing into the void like smoke. It spins in silence, unwitnessed, its story written only in heat and emptiness. And you drift on, grateful that your own story was written differently, grateful that in the desert of stars your world grew green. You leave behind the scorched exoplanet deserts, their molten rivers and trailing atmospheres, and you drift into another chapter of planetary fates. Not all worlds fail because they are too hot or too far. Some fail because they lose the very thing that breathes life into them, the atmosphere. You picture a planet naked under the stars, stripped bare, with nothing to shield it from radiation or to hold warmth against its skin. An atmosphere is more than just air. It is a blanket, a protector, a stage for weather and chemistry. Without it, a planet is silent stone. Hover now over Mercury, the innermost planet of the solar system. It is small, scorched, and nearly airless. Its gravity is too weak to hold much gas, and the sun's wind blasts away whatever whispers linger. The result is a surface baked during the day and frozen at night, swinging between temperatures that could fry an egg and freeze your tongue to metal in a single rotation. Imagine standing there, no air to breathe, no clouds, just brutal silence and a horizon that radiates heat one moment and chills the next. Mercury isn't even pretending to be habitable. It gave up on the atmospheric game before it began. Historians of science still argue how long Mars held on to its thicker air. Billions of years ago, Mars probably had a denser atmosphere, strong enough to support rivers and maybe even oceans. Then something changed. The leading theory is that Mars lost its global magnetic field early in its history. Without that shield, the solar wind stripped away the atmosphere over millions of years, thinning it until only a wisp remained. Imagine air being peeled off molecule by molecule, until the planet could no longer keep its water liquid. One slow theft, invisible but devastating. Here's your quirky tidbit. Earth's own atmosphere hasn't always been friendly. Billions of years ago, before oxygen filled the air, it was mostly methane, carbon dioxide and nitrogen. To you that would be poison, but to early microbes it was paradise. It wasn't until cyanobacteria invented photosynthesis that oxygen began to accumulate, paving the way for animals like you. The first atmosphere was a failed one, at least from your perspective. Failure summum and success depend entirely on who's trying to breathe. You drift toward an exoplanet discovered orbiting a red dwarf star. It lies in the habitable zone, the right distance for liquid water, but the star it circles flares often, blasting ultraviolet and X-rays. With every flare, chunks of the planet's atmosphere are stripped away. Over time, the air thins, water molecules split, hydrogen escapes, and the surface dries into a desert. You can almost hear the hiss of a world bleeding out, its chance at life dissolving into the void. Sarcasm slips in, so much for habitable zone. Astronomers love to call it the Goldilocks zone. Not too hot, not too cold, but here's the catch. Being in the zone doesn't guarantee soup or porridge, just as buying a stove doesn't guarantee dinner. If your stars is an unstable jerk, your planet ends up more like a scorched pot than a cozy breakfast. Atmospheres fail for many reasons. Some worlds are too small, their gravity unable to hold on to gases. Others orbit too close to their stars, heat puffing their atmospheres into space. Still others are pummeled by radiation, the molecules shattered and blown away. Without air, there is no weather, no shield against impacts, no cycling of gases to support life. A bare rock may be beautiful, but it is lifeless. You hover now over the moon, Earth's silent companion. It never had much of an atmosphere, its gravity too weak, its size too small. But some scientists think it might once have held a thin one, created by volcanic outgassing billions of years ago. If true, that air would have lasted only tens of millions of years before dissipating. The moon today is a fossil of a failed experiment, an almost world that never had a chance. Quirky break. In 1956, scientist Carl Sagan speculated that Venus's thick atmosphere might explain its mysterious brightness and radio emissions. At the time, some even imagined Venus's clouds were water vapor hiding lush jungles. Instead, they turned out to be sulfuric acid. It's a reminder that atmospheres can mislead you. What looks like paradise from afar can be poison up close. Historians of science still argue whether Earth's atmosphere is stable in the long run. Volcanoes, biological activity, and even human industry all tweak its composition. Some argue that Earth's balance is self-regulating, a feedback loop that stabilizes climate over eons. Others warn that tipping points, too much carbon, too little oxygen, could shift it toward failure as happened with Mars and Venus. The debate hums quietly unresolved. In every scientific paper and political conversation, you imagine yourself drifting through time, watching Earth's air shift like a mood ring. In one era, methane dominates, the sky tinted orange. In another, oxygen blooms, filling the air with fire's possibility. In yet another, carbon dioxide climbs, ice sheets melt, storms rage harder. The atmosphere is not fixed. It is alive, restless, fickle. That it has stayed friendly for billions of years is not destiny but chance, maintained by countless fragile interactions. Sarcasm stretches its legs again. If planets came with product labels, Earth's atmosphere would read, "Warning, content subject to sudden change. Keep away from large asteroids, volcanic tantrums, and ambitious primates with fossil fuels." And yet for now it works. For now you inhale oxygen, exhale carbon dioxide, and trust the invisible blanket to hold. You glide across another exoplanet, this one with no atmosphere at all. Its surface is cratered like the moon, scorched on one side, frozen on the other. Without air, there are no sunsets, no rainbows, no sounds. Sound cannot travel through vacuum. Imagine clapping your hands and hearing nothing, your palms stinging in silence. Imagine walking on a world where the sky is black even at noon, the stars unblinking. Atmosphere is not just breath, it is beauty. Without it, existence is stripped of colour and sound. Quirky note for your collection. Titan, Saturn's great orange moon, has the thickest atmosphere of any moon in the solar system, denser even than Earth's. Yet it is unbreathable, filled with nitrogen and methane. If you stood there, you could technically walk outside without a pressure suit. The air pressure is comfortable, but you'd suffocate in minutes. A cruel paradox. Air you can't breathe, rain you can't drink, rivers you can't swim. As you drift on, you realize atmospheres are fragile. They can be stolen, shattered, suffocated, or poisoned. And most worlds fail to keep them at all. Earth's success feels increasingly improbable. A balance of gravity strong enough, magnetism strong enough, distance right enough. Every breath you take is a reminder of a planetary miracle, one denied to most rocks spinning in the dark. Historians of science still argue how many exoplanets retain their atmospheres in harsh star systems. Each new telescope brings surprises. Planets with swollen, inflated skies, planets stripped bare, planets with exotic atmospheres of hydrogen, helium, or even metal vapors. The debate is far from settled, but the picture grows clearer. Failure is common, stability rare. Your eyelids droop as you picture one last scene, a planet losing its air. Molecules streaming upward into the void, the sky thinning, the silence deepening. Slowly the surface grows colder, drier, lonelier. It becomes just another failed world, another stone among billions. And you realise with a slow smile that your lungs fill with a gift you barely notice, a gift that most planets never keep. You leave behind the planets that cling to their stars, orbiting faithfully like children around a fire. Out here, in the deeper dark, you find the Wanderers, the worlds that lost their grip and were flung into interstellar night. Rogue planets, they're called, though the name makes them sound more rebellious than tragic. They are orphans of gravity, thrown from their families and left to drift alone through the cosmic cold. And there may be billions of them, scattered silently between the stars, unseen, unlit, uncounted. You imagine approaching one. From a distance, it's invisible. Without a sun to reflect, there's no sparkle to catch your eye. Only when you're almost upon it do you notice the faint glow of residual heat, a ghostly ember from its violent birth. The surface, if it has one, is frozen solid, temperatures plunging to hundreds of degrees below zero. No sunrise ever warms it, no season shifts, no dawn or dusk. Just eternal midnight, forever and ever. Historians of science still argue how these rogues form. Some may be planets born in normal star systems, then ejected by gravitational skirmishes with larger siblings. Others might have formed alone, collapsing directly from gas and dust like stars, but without enough mass to ignite fusion. The debate continues, unresolved, each discovery offering hints but no certainty. Here's your quirky tidbit. In T1, astronomers announced the discovery of a rogue planet candidate only about the size of Earth, drifting freely without a star. They spotted it using gravitational microlensing, a method where the rogue's gravity bends light from a background star, briefly magnifying it. It's like catching a shadow walking across a distant flashlight beam. For a moment you glimpse the invisible, and then it's gone again, back into the abyss. Imagine walking on such a world. The ground beneath your feet would be hard as iron, the air, if any, frozen into silence. Yet strangely, all may not be lost. Deep inside, a rogue planet could still hold heat from its formation, or even from radioactive decay. Beneath layers of rock and ice, subsurface oceans might linger, warmed by geothermal energy. On Earth, life clings to hydrothermal vents in the dark sea. Perhaps on rogues, similar pockets of warmth cradle unseen ecosystems, entire biospheres, never knowing starlight. Sarcasm stretches its arms here. Picture the real estate pitch. Own your very own rogue planet, enjoy endless nights, zero UV exposure, and guaranteed privacy from nosy neighbours. Downsides? Slight lack of sunlight and, well, any visible scenery. You can almost hear humanity's entrepreneurs scheming anyway. Someone would try to sell tickets. You float above another rogue, larger this time, perhaps the mass of Jupiter. Without a star, its thick atmosphere glows faintly from internal heat, radiating in infrared. No sunlight, no day or night, just a permanent dim glow, like embers of a dying fire. You wonder what it would be like to live in such a world. No sky to chart, no seasons, no concept of time beyond the ticking of your own heartbeat. Just endless wandering in the dark, knowing you will never see dawn. Historians of science still argue how common these rogues truly are. Some estimates suggest they may outnumber stars themselves. Imagine that, more worlds wandering alone than stars burning bright. The universe might be less like a cheerful neighbourhood of suns and more like a graveyard of lost children drifting between them. You let the thought wash over you, strange, heavy, comforting in its melancholy. You pause at the edge of one rogue planet's frozen crust. The ice stretches in endless plains, cracked and sculpted by ancient pressures. If you press your ear to the ground, you imagine hearing the faint hum of geothermal warmth below. Maybe water still flows in caverns, maybe microbes cling to chemical energy. Maybe life goes on in total darkness, content never to know stars. The silence makes it feel possible. Quirky fact for your pocket. In Japanese folklore, there's a wandering fireball spirit called Hitodama said to be souls drifting in the night. Rogue planets feel a little like cosmic Hitodama, glowing faintly in infrared, invisible to the naked eye, carrying mysteries across the black. Ghost worlds haunting the galaxy. Sarcasm sneaks back. Humans are obsessed with finding second homes, and yet here you have billions of rogues, free real estate, no star required. Of course, the catch is they're basically uninhabitable. No light, no warmth, no crops. It's like inheriting a mansion with no electricity or plumbing. Technically yours, but good luck living there. You drift further into the black, and the scale begins to sink in. Between stars, the distances are so vast that even light takes years to travel. A rogue planet in that gulf is utterly alone, perhaps never approaching another star system for billions of years. It is isolation at a scale you can hardly fathom, and yet it persists, still orbiting itself, still existing, still carrying the memory of the system that reshaped it. Historians of science still argue whether these rogues might occasionally brush close to star system, stirring comets, or even delivering materials. Some speculate that life, or at least the building blocks, could hitchhike on such wanderers spread across the galaxy in brief encounters. If so, then rogues aren't just failures. They are messengers carrying seeds through the dark, planting chances in unexpected places. You imagine lying on the frozen crust of one, looking up at a sky unchanging, stars sharp and unblinking. On Earth, you count time by sunrise and sunset. Here, you'd measure by heartbeats, or maybe by how often your stomach growled. No dawns, no twilights, just eternity. The thought is eerie, but also strangely peaceful. No deadlines, no seasons, no ticking clock, just the infinite pause of cosmic night. Quirky interlude. One rogue planet called CFB-DSIR 21149-0403 was announced in 2012. It's about 4 times the mass of Jupiter and drifts about 100 light-years away. Astronomers at first weren't even sure if it was truly alone or loosely bound to a distant star. That uncertainty sums up rogues perfectly. You can rarely tell if they're loners or just estranged relatives. They slip through definitions as easily as they slip through the dark. As you leave these orphans behind, you feel a tug of quiet awe. They are the ultimate failed worlds, planets without suns, exiled from the warmth of family. Yet they are also survivors. They continue to exist, to wander, to hold whatever secrets lie in their depths. Some may be sterile rocks, others hidden oceans, others glowing giants. They are tragedies, but they are also stubborn. Sarcasm makes one last bow. If Earth ever gets ejected into the void, maybe the tourism board can spin it. Introducing planet Earth, now with 100% more solitude, zero noise pollution, and unlimited starlight views. It's grim comfort, but also fitting. In the end, every planet is just one gravitational nudge away from exile. You let the image fade, the rogues drifting endlessly, invisible, countless, forgotten. They remind you that failure isn't always loud or fiery. Sometimes failure is just being alone, cast adrift in silence. And yet even that silence has its own kind of beauty. You close your eyes, imagining yourself a wanderer too, floating in the endless night, unhurried, unbothered, timeless. You drift away from the rogues, leaving them to their silent exile, and turn towards stranger failures, worlds where chemistry itself seems to rebel. If some planets die by fire and others by ice, these die by poison. Their atmospheres are thick with toxins, their surfaces steeped in substances you would never want to drink, breathe, or even touch. Yet they exist in abundance, each one a cosmic laboratory where bizarre experiments play out with no audience, failed trials written in fumes. Imagine a planet where the air is not air, but a brew of hydrogen sulfide, ammonia, and methane. You can almost smell it from orbit, like rotten eggs dunked in cleaning fluid. Any attempt to breathe would sear your lungs, strip oxygen from your blood, and leave you gasping in seconds. Yet in a twisted way, this is chemistry's playground. Reactions bubble and churn here that never occur on Earth, molecules colliding in exotic combinations. For you, poison. For the universe, just another experiment. Historians of science still argue whether early Earth itself might have resembled such a nightmare. Before oxygen rose in the air, your planet was a toxic stew. Methane, carbon dioxide, ammonia, even hydrogen cyanide swirling overhead. To you, instant death. To early microbes, paradise. What feels like poison to one era can be life's cradle in another. The debate lingers. Was Earth's early chemistry more like Titan's haze, or more like a simple carbon soup? The truth hides in a rock so ancient they barely remember. Here's your quirky tidbit. In the 9th century, scientists experimented with inhaling pure oxygen to see if it improved health. Spoiler, it didn't end well. Too much oxygen becomes toxic, damaging lungs and even the brain. The same gas that keeps you alive can kill you if the balance tips. It's a reminder that toxic is a relative word. Life is picky, but chemistry is not. Now picture an exoplanet circling close to a small cool star. Its skies are thick with methane haze, so dense the star's light filters through in a permanent orange glow. Temperatures might allow liquid methane rivers, not unlike Titan's, carving landscapes in strange patterns. Here, you drown not in water but in hydrocarbons, slipping into lakes that reek of gasoline. Imagine a boat ride across such a sea, your oars dripping with liquid fuel. For you, death. For chemistry, just Tuesday. Another world glimmers before you, its atmosphere laced with sodium and potassium vapours. Under the heat of its star, metals literally vaporize, drifting as clouds overhead. Rain here could mean droplets of molten iron or glass. You hover just above the haze, watching storms of glittering shards cascade downward. It's beautiful, like fireworks slowed into eternity, and completely uninhabitable. Sarcasm drifts in. Humanity loves to boast about resilience. We can live anywhere, deserts, tundra, mountain peaks. But then you meet a world where it rains molten glass sideways at 2,000 kilometers per hour, and you realize your so-called toughness is just adorable. Pack sunscreen if you want, it won't help. You turn your gaze toward Titan again, Saturn's giant orange moon. It deserves another glance because it may represent the strangest chemistry experiment of all. Its atmosphere is mostly nitrogen and methane, with complex hydrocarbons raining onto its surface, forming dunes of organic sand. Some scientists believe Titan could host a type of life radically different from Earth's, cells built from methane, with membranes made of exotic compounds. Historians of science still argue whether this is even possible. Biology has never been observed without water, but Titan whispers, maybe. Maybe life doesn't care about your rules. Quirky fact, in 1953, two young researchers, Miller and Urey, tried to recreate Earth's early atmosphere in a glass flask. They zapped it with electric sparks to mimic lightning. After a week, the flask turned brown, and inside were amino acids, the basic building blocks of life. From poison gases and lightning came the first ingredients of biology, a chemistry experiment that worked. It suggests that toxic atmospheres might not be failures at all, just misunderstood beginnings. You glide over another exoplanet, one so close to its star that the heat splits water molecules apart. Hydrogen escapes, oxygen lingers, leaving behind a world rich in corrosive O2. Sounds good, right? Free oxygen for everyone, except too much of it is unstable, reacting violently with surfaces, burning anything combustible. Walk there with a single spark, and the landscape could turn into a slow-motion inferno, atmosphere as dynamite fuse. Historians of science still argue whether Earth's great oxidation event was the planet's greatest success or its greatest near miss. Oxygen wiped out most anaerobic microbes, the ruling life forms of the time, in what some call the planet's first mass extinction. Oxygen was toxic waste to them, but a blessing to you. One species of poison, another's miracle. Chemistry doesn't choose sides, it just experiments. You linger now on a rogue planet again, this one with a thick hydrogen atmosphere clinging to it despite the cold. Without sunlight, it's frozen on the surface, but deep below, pressure and chemistry may allow exotic reactions. Hydrogen seas might slosh above rocky layers, carrying molecules unfamiliar to your textbooks. No warmth, no light, just alien chemistry in the dark. You can't help but wonder, does something crawl there, slow and strange, living not on sunlight but on reactions alone? Sarcasm nudges you. If humans ever find such creatures, the headlines will be insufferable. Aliens confirmed, they breathe poison, live in goo, and hate sunlight. Imagine the tourism ads. Visit exotic methane worlds. Experience death in 3 seconds or less. But beneath the jokes, a hum of awe remains. These toxic worlds remind you that failure isn't always absolute. What kills you might nurture something else. Life on Earth adapted to oxygen, sulfur, acids, extremes. Maybe somewhere, creatures sip ammonia instead of water, thrive in methane seas, or breathe hydrogen sulfide with joy. For them, Earth would be the toxic world, the failed experiment. Perspective shifts everything. Quirky break again. In the 1960s, scientists discovered microbes on Earth that metabolize arsenic, an element deadly to you. Later, says, in a much-debated 2010 study, another group suggested a bacterium might even incorporate arsenic into its DNA in place of phosphorus. The claim remains controversial, but it forced biologists to stretch their definitions of what's possible. If Earth can host such rebels, why not the stars? You drift farther, imagining these worlds not as barren but as alien laboratories, each one testing a different recipe. Some recipes collapse into poison, others bubble into potential. Billions of trials, billions of failures, but perhaps a few successes, just strange ones you wouldn't recognize. As you close your eyes, you picture a planet glowing under a star, raining molten glass into methane seas. Its air choked with sulfur and iron. You should recoil. Instead, you smile faintly, because even in their poison, these worlds remind you of possibility. The universe experiments endlessly, and sometimes what looks like failure is just another path waiting for the right eyes to see it. You leave behind the toxic seas and chemical smog of the last worlds, and now you arrive where fire reigns. Some planets don't fail because they are too cold, or because they lose their air, or because their chemistry is alien. Some fail because they never stop erupting. They are volcanic apocalypse worlds, places where the crust is nothing more than a temporary lid on the tantrums below, where mountains don't sleep but roar endlessly, reshaping the land faster than any life could adapt. The first such place you visit is Io, one of Jupiter's moons, and arguably the most volcanically active body in the solar system. Imagine standing here, if standing is possible, on a surface constantly rebuilt by lava fountains. Some of them blast hundreds of kilometers high, geysers of molten sulfur painting the skies yellow and red. The ground beneath you shifts daily, as if the entire moon is a conveyor belt of eruption. Craters don't last, mountains don't last, even footprints wouldn't last. Everything is buried and burned again and again. Historians of science still argue whether Io has any pockets of stability at all, or if the moon's surface has been entirely resurfaced every few million years. If so, it means Io has no fossils, no history preserved, just an eternal present of fire. Life here would be impossible in the way you know it. But if you're generous, you might whisper, maybe underground beneath all the chaos, some chemical cycle stirs. Here's a quirky tidbit. When Voyager 1 flew past Io, scientists were shocked to see volcanic plumes in the images. Until then, no one expected a small moon to host such drama. The discovery rewrote textbooks overnight. Imagine the surprise, sending a probe past what you thought was a frozen rock, only to find it spitting lava in your face. Io became proof that the universe loves to humble your assumptions. Now you drift toward exoplanets where Io's chaos is multiplied by size and heat. Astronomers have identified lava worlds, rocky planets so close to their stars that their surfaces are seas of molten rock. Temperatures climb to thousands of degrees, and any crust that tries to form is quickly melted again. Imagine orbiting such a planet, a glowing ember whirling around its star, half lit like a coal in a forge, never cooling. The lava tides here would dwarf anything on Earth. They are entire oceans of fire, restless, unending. Sarcasm leans in. Sure, humanity loves beach vacations, but this is ridiculous. Come to scenic lava world, sunbathe until your atoms vaporize, enjoy cocktails served in fireproof mugs, and marvel at our world-famous molten tides. Even the tourism board would give up after drafting the first brochure. But not all volcanic apocalypse worlds are close to stars. Some erupt because of their neighbours' gravitational tugs. Io's chaos, for example, is caused by Jupiter's pull, stretching and squeezing the moon until its interior heats and melts. It's a cosmic kneading. Imagine dough being folded and refolded, except the dough is rock, and the oven is space. The result is a world forever breaking out in volcanic rashes. Historians of science still argue whether similar tidal heating might sustain other moons, Europa, Enceladus, even Titan, providing enough warmth for oceans beneath the ice. Volcanism can destroy, yes, but it can also create niches for life, pumping heat and nutrients into cold environments. On Earth, hydrothermal vents teem with strange creatures, proof that fire and water can collaborate. Perhaps volcanic apocalypse worlds are not total failures, but strange incubators. You drift back in time to Earth's own volcanic tantrums. About 250 million years ago, during the Permian-Triassic extinction, vast volcanic eruptions in Siberia may have covered millions of square kilometers with lava, releasing greenhouse gases that choked the atmosphere and warmed the planet dramatically. Historians still argue about the details. Was it volcanoes alone, or did other factors join? Either way, life nearly ended. Earth itself flirted with becoming a volcanic apocalypse world. Here's another quirky note. The Deccan Traps in India, a massive volcanic region, erupted around the time the dinosaurs died. Some scientists suggest these eruptions, not just the asteroid impact, contributed to the extinction. Imagine lava fields stretching for hundreds of thousands of square kilometers, belching sulfur and carbon dioxide, poisoning the air. Dinosaurs didn't just face falling rocks from space, they also faced the Earth itself cracking open beneath them. Now you picture a planet larger than Earth, orbiting close to its star, its surface bubbling with volcanoes thousands of kilometers wide. Astronomers have speculated about super Eos, worlds so geologically active they glow like lanterns in infrared light. Imagine continents of lava, rivers of molten stone wider than oceans, skies thick with ash and fire. If life tried to crawl here, it would be buried before it took its first step, a reset button pressed again and again until the story could never begin. Sarcasm perks again. Earth's own volcanoes already cause flight delays and ash warnings. On these worlds, air travel would be, let's say, challenging. Imagine the safety announcement. Please fasten your seatbelt as we descend into an atmosphere filled with molten boulders. In the event of a lava storm, complimentary marshmallows will be provided. But even amidst the fire, you feel a strange comfort. Volcanism is destruction, yes, but it's also creativity. On Earth, volcanoes built islands, fertilized soils, and pumped gases into the sky that helped shape the atmosphere. Without them, perhaps no oceans, no air, no life. Even apocalypse has its gifts. Maybe somewhere, even a lava world hides moments of stability, where chemistry lingers long enough to take its first breath. Historians of science still argue whether volcanic activity is a prerequisite for habitability. Too little, and a planet's surface becomes sterile, its atmosphere stagnant. Too much, and it becomes Io or worse. Earth again threads the needle. Chaotic, but not too chaotic. Eruptive, but not endlessly so. A balancing act so precise it feels like luck. You hover once more over Io, watching fountains of lava arc into the sky, sulfur snow falling back onto the ground. You picture the exoplanets glowing in the dark, fireballs orbiting too close, their surfaces never still. They are failed worlds in one sense, too unstable for forests, too restless for seas. But in another sense, they are demonstrations. The universe is showing you the range of its imagination, from silence to fire, from ice to storm. As your eyelids droop, you let the fiery images blur. Volcanoes roar in your mind, but their sound softens, more like distant thunder. Lava rivers glow in your imagination, but they cool into gentle embers. Even apocalypse, seen from afar, can soothe. You float away from the fire worlds, carrying their lesson. Survival depends not just on heat, but on balance, on knowing when to erupt and when to rest. You drift now from the firestorms and lava oceans, away from worlds that roar with too much energy, into the opposite extreme, the quiet giants. These are planets that look promising at first glance. Large, stable, not too chaotic, not too barren. They orbit calmly, their surfaces unscarred by constant impacts, their skies unbroken by storms, and yet they fail in another way. They are too calm, too still, too unchanging to encourage the messy, unpredictable chemistry that makes life possible. In their silence, they are sterile. Imagine gliding over a super Earth, a rocky planet 2 or 3 times larger than Earth. Its gravity holds its atmosphere tightly, keeping it thick and stable. There are no catastrophic volcanoes here. No violent weather systems, no storms tearing the land. Instead, the air is heavy, unmoving, and the surface is locked in a monotony of calm. Lakes lie still for millennia. Mountains barely erode. The climate hardly shifts. To you, it might feel peaceful, but peace is not always fertile. Life thrives on change, on cycles, on tension between extremes. Too much calm, and nothing stirs. Historians of science still argue whether such super-Earths could support biology. Some suggest they would be perfect, ample gravity to keep air and oceans, less chaos to destroy ecosystems. Others counter that without tectonics, weather, or variability, evolution stalls before it begins. The debate remains unresolved, but one thing feels clear. A planet that never changes is a planet that never surprises. Here's a quirky tidbit. In the early 1600s, the philosopher René Descartes imagined that planets might be formed by swirling vortices of subtle matter. He thought the universe was full of whirling, quiet systems spinning predictably forever. He was wrong about the physics, but oddly right about the idea of planetary quiet. Some worlds truly are just endless spins with no drama, no fire, no spark. Now picture yourself landing on one. The gravity pulls harder than you expect. Every step feels like wading through mud. The atmosphere presses on your chest, thick but breathable if the gases were right. You walk across a plain of rock and see nothing. No storms, no quakes, no eruptions, not even wind strong enough to shift dust. You sit down and hours pass, then days, then years. The sky barely changes. The silence becomes oppressive, not calming. A world that never moves begins to feel like a tomb. Sarcasm stirs. Humans complain about boredom if the Wi-Fi goes out for 10 minutes. Imagine living on a planet where nothing ever changes for 10,000 years. No storms, no sunsets worth watching, no new landscapes. The biggest drama is maybe a rock falling down a hill once a century. Congratulations. You've won front row seats to the world's most boring apocalypse. And yet, these quiet giants are common. Astronomers suspect that many super-Earths orbit other stars. Some may be habitable in the technical sense. The right temperature, the right atmosphere, the right distance from their star. But technical habitability is not the same as thriving life. Earth's liveliness comes from imbalance, from plate tectonics recycling carbon, from weather systems that stir the air, from ice ages and warm periods that push species to adapt. Too much stillness, and the wheel of evolution never turns. Historians of science still argue whether plate tectonics is unique to Earth. Some claim super-Earths, with their stronger gravity, might actually have super tectonics, continents breaking and shifting even more vigorously. Others argue the opposite, that their crusts would be too rigid, locked in place, silencing the recycling process. The truth is hidden beyond your telescopes, waiting in the rock of unseen worlds. Here's your quirky break. In 2017, scientists discovered a planet called LHS 1140b, a super-Earth in the habitable zone of a red dwarf star. It quickly became a favourite candidate for study. Stable orbit, dense composition, maybe a thick atmosphere. On paper, perfect. But some skeptics dubbed it boringly habitable. A world that might check every box, yet produce nothing beyond puddles and rocks. Imagine travelling across light years just to find the cosmic equivalent of an empty parking lot. You hover now above another type of quiet giant, the ice giants Neptune and Uranus. Their atmospheres are blend from afar, gentle blues, faint clouds, but beneath the calm lie exotic chemistries, layers of ice and gas stacked for tens of thousands of kilometres. They are neither as dramatic as Jupiter nor as violent as Saturn. They are background planets, quiet presences at the edge of the solar system. Beautiful, yes, but distant, aloof, detached. They don't roar, they don't flame, they don't invite, they just exist. Sarcasm sidles back. If Earth were more like Neptune, human culture would be drastically different. No storms to inspire myths, no volcanoes to terrify or bless, no fertile soil for crabs. You'd probably still be squatting in caves, staring at each other like, well, it's Tuesday again, just like the last 200,000 Tuesdays. Quiet may sound like paradise until you live in it. But there's a strange kind of tragedy in these worlds. They fail not because they're hostile, but because they're indifferent. No wars of fire, no exiles into cold, no dramatic collapses, just nothing. They are the planets that could have been, the ones that never risked enough to ignite life's spark. They remind you that failure isn't always dramatic. Sometimes failure is science. Historians of science still argue whether Earth itself might someday become too quiet. Billions of years from now, as the interior cools, tectonic activity may stop, volcanoes may die, weather may stabilize into monotony. Earth could join the gallery of quiet giants, no longer erupting, no longer shifting, just a fossil spinning around a sun already burning out. If so, then silence waits even for success. Quirky interlude. Ancient Chinese records from around 1000 BCE describe how people believed the Earth was perfectly stable and unchanging. The sky moved, but the land was fixed. That worldview fit a quiet planet. Only later did earthquakes and eruptions convince them that the Earth was restless. For some worlds, that early belief would be true, unchanging forever. For Earth, it was only half the story. As you drift, you picture these quiet giants lined up like statues, their surfaces polished by time, their skies unmoved by storms. They are monuments, not stages. You can almost hear them whisper, "We could have been something," but they aren't. They wait, endless, serene, sterile. Sarcasm closes in with one last quip. You know the saying, may you live in interesting times? Well, may you also live on interesting planets. Because the alternative is spending your life watching rocks erode millimetre by millimetre while absolutely nothing else happens. That's not peace, that's cosmic boredom. And yet, as you let your eyes soften, you find the quiet has its own lullaby. These giants hum softly in the background, their monotony stretching like a blanket. They are reminders that not every world must roar or shine. Some fail simply by doing nothing, by staying too calm, by waiting forever. You float away from them with your breath slow, your body heavy, lulled by their silence, grateful your own world is restless enough to dream. You drift outward again, past the quiet giants, until the stars themselves seem to scatter more thinly. Here you encounter not planets in motion, but the ruins of worlds already gone. The galaxy holds grave markers, silent testimonies to lives that never were or that ended before they began. These are the wreckages, the shattered planets, the pulverized moons, the debris fields orbiting nothing. To float here is to walk through a cosmic cemetery where every stone has been carved by collision, fire, or neglect. Imagine a planet struck by an asteroid the size of a city. The surface melts on impact, shockwaves rip across continents, and mountains crumble like sandcastles. If the blow is strong enough, the planet itself can be destroyed, fragments scattering into belts of rock. This is how astronomers believe the asteroid belt between Mars and Jupiter formed. The remnants of a planet that never quite assembled, shattered by Jupiter's gravity and left as a broken memorial. Each asteroid is a tombstone spinning in silence, whispering, "We could have been something." Historians of science still argue whether the asteroid belt is really a failed planet or simply leftover material that never had the chance to coalesce. Some say it's a shattered world, others say it's just cosmic crumbs. Either way, it is a graveyard, a reminder that not every pile of stone gets promoted to planet. Here's your quirky tidbit. In 1801, when astronomers discovered the first asteroid Ceres, they thought they had finally found the missing planet predicted to exist between Mars and Jupiter. They celebrated briefly, till they realised Ceres was tiny, barely 1/13 the size of Earth's moon. More discoveries followed, each one small, each one a fragment. The excitement faded, replaced by the melancholy recognition that this wasn't a world but a scattering of funerary rubble. Now picture drifting across a ring system, like Saturn's but far messier. Some rings aren't made of ice and dust alone. Some may be the remains of moons torn apart by gravity. When a body strays too close to its planet, tidal forces rip it apart, aren't we? Scattering pieces into rings that orbit as shimmering bands. They look beautiful, but they are cemeteries too, memorial wreaths circling a giant that pulled its child apart. You float onward and encounter a white dwarf star, the collapsed ember left behind when a sun like ours dies. Around it, astronomers have detected debris disks of rock and dust, evidence of planets shredded as their star swelled into a red giant and then collapsed. Imagine watching your own sun balloon outward, billions of years from now, swallowing Mercury, Venus, and perhaps Earth. The survivors, if any, will be broken into rubble circling a ghost star, grave markers glowing faintly in ultraviolet light. Sarcasm slips in. Humans like to think of headstones as permanent, but compared to planetary ruins, they're temporary graffiti. Somewhere in the galaxy, a ring of shattered planets has been spinning for billions of years. Meanwhile, the inscription on Grandpa's headstone back home is already fading after 50 summers. The universe keeps its memorials in motion. You hover above another tragic case. Exoplanets so close to their stars that they are being torn apart piece by piece. Their rocky material streams outward, forming tails like comets. From afar, they look almost elegant, glowing trails stretching across space. But up close, it's disintegration. An entire world evaporating, leaving only dust to mark its passing. Some of these planets may vanish entirely within a few million years, reduced to nothing but faint halos around their stars. Historians of science still argue how many such worlds exist. Are these rare catastrophes, or are they common endings for planets too close to the furnace? Each telescope pass reveals new hints, but the count keeps growing. If common, then grave markers may be one of the most abundant features of galaxies, ruins outnumbering thriving worlds. Here's a quirky story for your collection. In 2015, astronomers studying a white dwarf star saw irregular dips in its brightness, as though clouds of debris were orbiting it. Some speculated they were watching the slow disintegration of a planet or large asteroid, its remains drifting like ash around the dead star. It was, in essence, the galactic equivalent of watching a funeral procession from across town, faint shadows marking the end of something grand. You wander into another type of grave marker, impact scars. The moon is covered in them, each crater a silent obituary. Mercury too, its surface pocked and scarred. Even Earth carries its share, though erosion and plate tectonics erase many. The Chicxulub crater in Mexico is one of the best known, the scar left by the asteroid that ended the dinosaurs' reign. It's a reminder that grave markers are not always for entire planets. Sometimes they're for eras, for lineages, for chapters in a planet's history. Sarcasm cuts through. Earthlings like to keep photo albums of lost pets and family members. The universe? It prefers to keep its records in craters the size of countries. Nothing says we remember you quite like a hole visible from orbit. You pause and picture walking across such a grave marker. The ground is uneven, rubble piled into ridges, dust drifting into shadows. The silence is immense, but you can feel the weight of history pressing against your chest. You know nothing grew here, nothing will grow here, and yet the place feels sacred. Absence itself is the memorial. Historians of science still argue how much of Earth's own crust hides buried markers of forgotten impacts. Some suggest the early Earth endured constant bombardment, an era called the Late Heavy Bombardment, when asteroids rained so heavily that entire oceans boiled away. If true, then Earth's survival is almost absurd. The grave markers of that era have been mostly erased, recycled by tectonics, but their echoes linger in old zircons and minerals. Quirky interlude. Ancient cultures often mistook craters for divine marks. In Arizona, the massive Barringer crater was once believed to be a volcanic vent until modern geology proved otherwise. The idea that the sky itself could carve scars into the Earth was too unsettling, yet the planet you sleep on is littered with these quiet signatures. You float now through the Milky Way, seeing it not as a swirl of stars but as a gallery of graves. Each asteroid belt a failed planet, each ring system a torn moon, each white dwarf halo a shredded world. The galaxy keeps no monuments carved of stone, but its memorials are everywhere, circling, glowing, colliding, dissolving. Sarcasm makes one final cameo. If the universe had a graveyard tour, humans would sign up in droves. Visit our famous planetary ruins, see the shattered remains of once promising worlds, admission free, oxygen not included. You laugh softly because it's true. Humans can't resist ruins, whether Roman amphitheatres or cosmic debris. And as you drift from these galactic grave markers, you feel a strange peace. Failure leaves beauty behind, even in rubble. The craters, the rings, the dust, they are reminders that endings are not always empty. Sometimes they are art, painted on the canvas of the galaxy, waiting for anyone with eyes to see. You close your own eyes now, heavy, letting the ruins blur into memory. The graves are endless, but so is the silence they keep. You drift back toward home now, leaving the grave markers of shattered worlds behind. It feels strange, almost guilty, to return to Earth after walking through so much failure. Your planet, after all, sits on a razor's edge. It may look stable, blue oceans gleaming, clouds drifting gently over green land, but its history is a long series of near misses. Earth has been punched, burned, frozen, and nearly strangled more times than you can count. If you think of it as a casino ticket, it's not just the winner, it's the winner that almost got shredded in the machine before the jackpot rang. Start with the most famous close call, the asteroid that ended the age of dinosaurs. 66 million years ago, a rock about 10 kilometers wide slammed into what is now Mexico. The impact released energy equivalent to billions of nuclear bombs, boiling seas, igniting forests, and filling the atmosphere with dust so thick sunlight barely reached the ground. Plants died, food chains collapsed, 3/4 of species vanished. But life itself survived, tucked away in burrows, underwater, in niches the fire couldn't touch. You're here tonight because a few small mammals made it through. If that asteroid had been a little larger, or struck a slightly different angle, Earth might be just another silent grave marker. Historians still argue whether the asteroid alone caused the extinction or if volcanic eruptions in the Deccan Traps of India piled on, belching carbon dioxide and sulfur into the sky at the same time. Maybe it was a 1-2 punch, nature's cruel Kwan combination move. Either way, it was a near miss for the planet's long-term survival. Dinosaurs lost, you won by default. Here's your quirky tidbit. Some paleontologists suggest that if the asteroid had missed, dinosaurs might still dominate Earth today. Mammals might have stayed small and nocturnal, never evolving into apes, never building cities, never recording sleepy science documentaries. Somewhere out there in a different timeline, a velociraptor may be writing bedtime scripts. Comforting or terrifying? Hard to say, but that wasn't the only brush with annihilation. About 2.4 billion years ago, Earth's atmosphere filled with oxygen for the first time in what's called the Great Oxidation Event. Sounds like progress, right? Except oxygen was toxic to most of the microbes alive then. It poisoned their enzymes, destroyed their cells, whole ecosystems collapsed. It was Earth's first global mass extinction, triggered by the very gas you now depend on. Life had to adapt or perish. Fortunately, some microbes learned to breathe oxygen instead of choking on it, and evolution staggered onward. But the planet almost suffocated in its own waste. Sarcasm sneaks in. Imagine that headline. Breaking, planet poisoned by fresh air. Billions of microbes protest. Demand return to methane skies. If Earth had a social media back then, the outrage would have been spectacular. Another close call, the Snowball Earth episodes. Roughly 700 million years ago, the planet may have frozen almost completely. Oceans locked under kilometers of ice. Continents buried in glaciers stretching to the equator. Sunlight reflected off the ice, cooling Earth further in a vicious feedback loop. If the freeze had lasted too long, photosynthesis might have collapsed, and life could have ended. But volcanic eruptions slowly pumped greenhouse gases into the air, warming the planet just enough to thaw. Earth blinked awake from its icy coma. You owe your existence to a few stubborn volcanoes that refuse to quit. Historians still argue how total these snowball episodes were. Some say ice reached pole to pole, locking everything. Others think belts of open water survived near the equator, near refuges where life clung desperately. The debate continues, but either way, Earth came terrifyingly close to becoming a frozen tomb. Quirky break during the 1815 eruption of Mount Tambora in Indonesia. The ash cloud cooled the globe enough to create the year without a summer. Crops failed, famine spread, and in Europe, people huddled under grey skies. Out of that misery, the poet Lord Byron challenged his friends to write ghost stories by candlelight. Mary Shelley's Frankenstein was born in that strange volcanic summer, proof that even near misses and temporary climate chaos can spark creativity. You move forward in time to another planetary crisis, the Permian-Triassic extinction 252 million years ago. Often called the Great Dying, it wiped out more than 90% of species. Vast volcanic eruptions in Siberia released so much carbon dioxide that the climate swung violently, oceans acidified, and ecosystems collapsed. Earth almost reset completely, almost emptied itself. Life survived, but just barely, staggering forward with fewer cards left in its deck. Sarcasm presses close. If Earth were a student, it would be the kid who shows up to the final exam 5 minutes late with a broken pencil, covered in coffee stains, and somehow still passes. Barely. But a pass is a pass. Even smaller events carry their near-miss weight. About 74,000 years ago, the eruption of Mount Toba in Indonesia may have triggered a volcanic winter. Some scientists believe global temperatures dropped enough to squeeze humanity's population down to just a few thousand survivors. Your entire species may have hung on by a thread, one stormy season away from erasure. Historians still argue how severe the bottleneck really was, but the idea alone is chilling. All of human culture might descend from a handful of families huddling by fires, hoping the skies would clear. Another brush came from the cosmos. In 1908, a meteor exploded over Tunguska, Siberia, flattening thousands of square kilometers of forest. If it had hit a city, millions could have died. In 2013, another smaller meteor exploded over Chelyabinsk, shattering windows and injuring hundreds. Earth dodges bullets constantly. Most never reach the news. Somewhere in the darkness tonight, another rock is already tumbling toward your orbit. The casino wheel keeps spinning. Here's a quirky story. In 1989, an asteroid named 89 FC passed within 700,000 kilometers of Earth, less than twice the distance to the Moon. Astronomers didn't spot it until it had already gone by. It was big enough to have caused global damage. Imagine waking up to find out you almost died yesterday, and nobody even knew until after. Earth's survival sometimes comes down to dumb luck. Historians of science still argue whether life's resilience is stronger than its fragility. Each catastrophe wiped the slate, but each also opened niches for survivors to flourish. Without the Great Dying, reptiles might never have dominated. Without the dinosaur extinction, mammals might never have risen. Without Toba, humanity might never have spread so widely. Survival sometimes feels less like triumph and more like stumbling forward after being shoved. As you hover above Earth, you see it not as a calm oasis, but as a scarred survivor. Craters dot its crust, though many are hidden. Volcanoes rumble, though most slumber. Ice sheets wax and wane. Forests burn and regrow. The planet looks peaceful now, but beneath that peace lies a history of chaos barely dodged. Every bird in the trees, every person under a lamp, every breath you take is a monument to chance. Sarcasm bows one more time. Humans planned 5-year budgets, long-term retirement accounts, and ambitious colonization projects. Meanwhile, Earth has dodged fiery rocks, toxic skies, and global ice ages by margins thinner than your phone screen. You might want to keep your receipts, and yet the near misses themselves become a lullaby. Because if Earth can endure this much chaos and still cradle life, then maybe survival isn't quite as improbable as it feels. Maybe balance emerges not from perfection, but from resilience. You let that thought settle in your chest. Fragility, yes, but also tenacity. Earth has stumbled again and again, but it hasn't fallen yet. As your eyelids droop, you picture the planet from above, glowing blue in the night, scars hidden beneath clouds. Near misses trail behind it like ghosts, reminders of how close it came to failure. But tonight it spins on, alive, steady, generous. The wheel keeps turning, and for now, you're still on the winning side. You hover above Earth, reflecting on all those close calls, and now another truth dawns on you. Survival hasn't just been about dodging disaster, it's also been about absurdly lucky coincidences, little alignments of physics and chance that tip the scales toward life. Without them, your world might be as barren as Mars, as scorched as Venus, or as silent as the rogue wanderers you drifted past earlier. Tonight you let yourself marvel at just how improbable that this whole arrangement is. Start with the Moon. That accidental sibling, born from a colossal impact billions of years ago, ended up being more than just a nightlight. Its gravity stabilizes Earth's tilt, keeping the climate relatively steady over long timescales. Without it, Earth might wobble chaotically, tilting one way for a while and then another, producing extreme seasons or even flipping onto its side. Imagine summers where the sun never sets for decades, followed by winters where it never rises. Not exactly garden party weather. Instead, the Moon keeps Earth balanced enough for forests, ice ages, and civilizations to emerge. One lucky smash created the perfect dance partner. Historians still argue how unique this moon-making collision really was. Was Earth's giant impact one of countless similar events, or an almost singular freak accident? Some argue that without the Moon, advanced life would never have evolved here. Others believe Earth would have muddled through regardless, adapting to chaotic tilts. The debate hums quietly in scientific journals, unresolved but tantalizing. Here's your quirky tidbit. Some scientists think Earth's tides, pulled by the Moon, may have played a role in life's early steps onto land. Tidal pools offered cycles of wet and dry, concentrating organic molecules and forcing adaptations. In a way, you owe your existence to long afternoons spent splashing in puddles 4 billion years ago. A cosmic coincidence turned into a family tree. Now tilt your gaze to Earth's orbit. It lies not too close, not too far in what astronomers call the habitable zone. You've heard the cliché before, Goldilocks, not too hot, not too cold, but the detail is more exquisite than the nursery rhyme suggests. Earth's orbit is almost perfectly circular, not wildly elliptical. That means the planet doesn't swing drastically closer or farther from the sun each year. Seasons are gentle, climate is stable, and life has the breathing room it needs. A few percentage points different, and the story could have unraveled. Sarcasm stirs. Humans often argue whether they're lucky if their bus arrives on time, or if their online order isn't delayed. Meanwhile, Earth managed to lock in a stable orbit for billions of years while dodging asteroids, avoiding Venus-style greenhouse collapse, and hosting just enough tectonic chaos to recycle nutrients. If that's not luck, your definition may need updating. Consider too the Sun itself. It's not too big, not too small, not too volatile. A little larger, and it would burn through fuel too quickly, roasting Earth or swelling into instability before life had much of a chance. A little smaller, and its habitable zone would shrink, leaving Earth outside the warmth, frozen solid. But your Sun burns at a steady pace, bright enough to light oceans and gentle enough to last billions of years. Its flare activity is mild compared to many stars, sparing Earth from constant radiation barrages. Out of all the kinds of stars, humanity just happens to orbit the boring one, which, in cosmic terms, is the jackpot. Historians of science still argue about the role of Jupiter in this luck. Some call it Earth's shield, a giant whose gravity deflects comets and asteroids that might otherwise smash into your planet. Others argue Jupiter sometimes does the opposite, flinging dangerous rocks directly toward Earth. The debate is unresolved, but the fact remains. Without such giants shaping the solar system, Earth's history would look very different. Whether protector or bully, Jupiter's presence helped sculpt the odds. Here's another quirky morsel. Earth's axial tilt of about 23.5 degrees is just right for seasons, enough to create variation, but not so extreme as to destabilize ecosystems. A tilt of 0 would mean no seasons, eternal sameness. A tilt of 60 would mean climate chaos, poles baking in sunlight then freezing in darkness. Instead, you get spring blossoms, autumn leaves, snowfalls, and rainy summers. A perfect tilt courtesy of cosmic chance. Zoom in now to Earth's interior. The planet's molten core churns and spins, generating a magnetic field. That invisible shield deflects solar wind, preventing the atmosphere from being stripped away like Mars's was. Without it, Earth's air might have vanished long ago. The fact that Earth is just large enough, just hot enough, just radioactive enough inside to keep this dynamo running? Another coincidence. You sit here breathing oxygen only because molten iron continues to swirl beneath your feet. Sarcasm grins, so the next time someone brags about their lucky streak at the casino, remind them their real lucky streak is the magnetic bubble surrounding their planet. No bubble, no air, no bragging rights. Historians of science still argue how finely tuned these coincidences must be. Some claim life is robust enough to arise under many circumstances, that luck is overrated. Others argue the window is far narrower, that the smallest tweak, a weaker field, a missing moon, a slightly different orbit, would erase you this entirely. The truth, as always, is somewhere tangled in between, and then there's water, not just its presence, but its abundance. Earth has just enough water to cover its surface, but not so much that it drowns its continents. A little less, and deserts might dominate. A little more, and Earth could be a water world with no dry land, no continents for complex ecosystems to evolve. Even the ratio of oceans to land is suspiciously lucky. Too balanced, too perfect, too convenient. Quirky note, scientists believe much of Earth's water may have been delivered by asteroids and comets in the early solar system. It wasn't guaranteed. Your oceans are hand-me-downs, cosmic care packages thrown at Earth during its chaotic childhood. The universe didn't have to share, but it did. You pause now, letting all these coincidences settle in your chest. The moon stabilizing, the orbit smoothing, the tilt balancing, the core protecting, the oceans filling. Each factor might seem ordinary when taken alone, but together they weave a tapestry of improbable survival. Too many threads pulled, and the whole cloth unravels. Sarcasm leans close for one more whisper. Earth basically won the galactic lottery, and still managed to invent Monday mornings, traffic jams, and reality TV. If that doesn't prove humans can waste a miracle, nothing will. And yet, the miracle remains. As you breathe in, oxygen fills your lungs because microbes, billions of years ago, learned to photosynthesize. As you exhale, carbon dioxide floats upward into an atmosphere kept in place by a magnetic field. Above you, the sky's blue because sunlight scatters through a mix of nitrogen and oxygen. Gases held stable by Earth's size and orbit. Everything feels ordinary. but every ordinary moment rests on coincidences so rare they could fill a universe with failures before repeating. As your eyelids grow heavy, you picture Earth again, not as a random rock, but as a fragile machine with pieces that happen to fit together. A moon dancing at just the right distance, a sun burning at just the right pace, a crust shifting just enough to recycle, a tilt angle just enough to stir. All of it coincidence, all of it luck. And yet, here you are, listening, breathing, surviving. The ticket was punched and somehow you got in. You hover in orbit above Earth, still marvelling at its lucky coincidences. And then a sobering thought creeps in. How many other worlds might have come close to similar luck, only to stumble just before the finish line? How many almost Earths spun in distant systems, oceans shimmering briefly before drying out, atmospheres thickening into poison, magnetic fields collapsing too soon? You realise that if life began on some of those worlds, their histories are forever sealed, erased by catastrophe or silence. Entire civilizations could have flickered and gone, leaving no trace except the unvisited stone beneath distant suns. They are the histories you'll never read. You drift past the notion of Mars again, remembering its ancient valleys. Maybe life began there, tiny microbes swimming in streams clinging to rocks. If they thrived for a time, their story was cut short, a lost chapter hidden under dust. You can almost imagine what Martian textbooks might have held if such creatures had evolved further. Chapter 1, Surviving the Thin Air. Chapter 2, When the Rivers Ran. But those books were never written. If Mars had its own Shakespeare, its own Confucius, they were erased before the ink could dry. Historians of science still argue whether microbial life ever truly existed there. Some claim the evidence is too weak. Others insist the hints are undeniable. The debate remains unresolved. Hanging like a page half torn from a diary, the truth may lie frozen underground, locked in brines or fossils, waiting for someone to dig. Until then, the story stays hidden. Here's your quirky tidbit. In 76, NASA's Viking landers carried experiments designed to detect Martian metabolism. One test, called the Labeled Release Experiment, seemed to show a positive result. Gas emitted as though microbes were digesting nutrients, but other experiments contradicted it, and the scientific community has been divided ever since. Decades later, the debate is still alive. Imagine a world where that one experiment had been clearer, a world where the history of life on Mars was obvious. You'd be writing Earth's story very differently tonight. You drift farther outward, picturing rogue planets wandering in the dark. If any of them once hosted civilizations before being ejected from their systems, what remains now? Whole histories could be entombed under ice, libraries frozen beneath crusts, monuments drifting unlit in eternal night. You'll never read their poetry, never see their cities, never know their myths. The silence hides not just absence, but possibility erased. Sarcasm tiptoes in. Humans already complain about lost emails, deleted phone photos, or corrupted hard drives. Imagine the cosmic equivalent. Entire worlds deleted, their data gone, their stories unsaved. The universe is the worst cloud storage imaginable. Now picture an exoplanet circling a red dwarf star. Red dwarfs are notorious for violent flares, bursts of radiation strong enough to sterilize planets. Maybe a world there once bloomed, oceans rich with life, only to be wiped out by repeated star tantrums. Imagine civilizations building shelters, writing their stories underground, desperately trying to endure, until one flare too many ended it. All their songs, their inventions, their languages, gone. The library burned before anyone else could visit. Historians of science still argue about the Fermi paradox. If the universe is so vast and full of planets, where is everyone? One haunting possibility is that civilizations do arise but rarely last. They collapse before they can spread, their histories sealed away on failed worlds. You're left staring into the dark, surrounded by books that will never be opened. Here's a quirky interlude. In the 1960s, scientists discovered mysterious radio signals called pulsars. At first, they were so regular and precise that researchers half-jokingly nicknamed the first one LGM-1, short for Little Green Men. For a brief moment, it looked like you might be reading someone else's history, tapped out in radio waves. Instead, it was just a neutron star spinning like a lighthouse. The disappointment was sharp but also telling. You want to find other stories. You ache for them. You hover now over Earth's own fossil record. Even here, most of history is missing. Of all the species that have lived, more than 99% are extinct, their bodies recycled, their stories erased. You will never know what songs dinosaurs might have sung, what gestures trilobites might have used to greet each other, what colours extinct birds flashed in forests now gone. Even on your own world, most histories are unreadable. Stone remembers only fragments. Sarcasm sighs. Humans build museums and libraries as if permanence is guaranteed. Yet the universe laughs. Tectonics, erosion, impacts and time erase almost everything. You're living on a planet with amnesia where only scraps survive. The grand majority of life's history has already slipped between the cracks. And still you can't help but imagine. What if a super-Earth somewhere nurtured a species that built towers of glass and light, only to collapse in a war or famine or environmental spiral? What if a Titan-like moon sprouted methane-breathing creatures that crafted myths under orange skies, but were frozen out when the climate shifted? What if Venus itself once hosted oceans, shallow and warm, with bacteria or even fish, before its atmosphere turned traitor? The possibilities multiply, and each one feels like a library burned. Historians of science still argue whether Earth itself holds signs of prior civilizations, not dinosaurs building rockets, that's fringe nonsense, but industrial species that could have risen and fallen long before humans. The Silurian hypothesis suggests that if such a civilization existed hundreds of millions of years ago, most of its evidence would already be erased by tectonics. Plastics, metals, cities, all gone, leaving only faint chemical anomalies in rocks. It's unlikely, but not impossible. Even your own history might be unread. Here's a quirky note. In 2018, researchers found microfossils of bacteria that are at least 3.5 billion years old in Australia. They look like filaments, tiny structures preserved in ancient rock. That's one of the few direct glimpses into Earth's earliest history. Billions of years, and all you get are faint threads of stone. Imagine how much more is gone. You pause and let the weight settle. The galaxy may be filled with stories erased before they could spread. Civilizations may have written poetry in languages no one will ever hear. They may have painted, sung, loved, fought, and all of it vanished. The silence of the universe might not mean absence, but erasure. Sarcasm leans in for one last whisper. Humans can't even keep track of their car keys or remember what they had for breakfast yesterday. And yet they expect the galaxy to have perfect archives of every civilization? Please, the universe is a forgetful librarian. And most of its shelves are empty. Still, the thought doesn't depress you. It soothes you strangely. Because if all those unread histories existed, then life is not unique to Earth. And even if their stories are gone, the fact they might have existed at all means you're part of something bigger. A chorus, even if only one voice remains audible. As your eyes grow heavy, you picture yourself walking through an endless library of blank books. Each represents a world erased, a history unread. You run your fingers along the spines, imagining the words that once filled them. You'll never read them, but that doesn't mean they were never written. And that possibility alone is enough to lull you deeper into the quiet. You float among those unwritten histories, the lost libraries of other worlds, when a different thought sneaks into your mind, half a joke, half a whisper, the kind of idea that keeps philosophers awake and makes insomniacs sigh. What if none of this is even real? What if Earth, the moon, the gas giants, the rogues, the grave markers, what if they're all part of some grand simulation? A cosmic test run running on machinery you'll never see? The whisper is everywhere in modern culture. Maybe you're not just alive in a rare world, but inside someone else's experiment. You let the thought linger. If Earth feels improbably lucky, so finely balanced and filled with coincidences, maybe that's because it was designed to be. Maybe someone, or something, wrote the code, pressed play, and is now watching you the way you watch ants in a glass farm. Your oceans, your atmosphere, your very memories might be nothing more than lines of data in a server room you'll never visit. The simulation whisper asks you to doubt not just your place in the universe, but the universe itself. Historians of philosophy still argue about the seriousness of this idea. Some dismiss it as sci-fi fun, cocktail party speculation. Others, like the philosopher Nick Bostrom, argue it's a real possibility. His reasoning is blunt. If advanced civilizations exist, they might run countless simulations of their ancestors. If they do, then statistically you're more likely to be in one of those simulations than in the single, real universe. The argument is unsettling precisely because it feels hard to disprove. Here's your quirky tidbit. In 2003, a group of MIT students pulled a prank by creating a fake website that claimed to detect glitches in the Matrix. It offered tongue-in-cheek explanations for déjà vu, strange coincidences, and lost socks in the dryer. Thousands of people visited, some convinced it was real science. It wasn't, of course, but it tapped into something deep, that nagging suspicion that reality itself occasionally hiccups. Now picture yourself floating over Earth again, but with simulation eyes. The continents look less like land and more like rendered polygons. The oceans ripple as though programmed, their waves repeating subtle patterns. The stars twinkle not from atmospheric scattering, but from graphic limitations. Even your breath feels coded. Each inhale a variable, each exhale a line of script. You're not flesh, but data. Not alive, but computed. The whisper grows louder. Sarcasm nudges in. If this is a simulation, then whoever's running it clearly has a questionable sense of humour. Mondays, mosquitoes, taxes, Wi-Fi dead zones, all bugs that should have been patched in the last update. And yet here you are, still dealing with them, which suggests either the programmers are lazy, or they enjoy watching you squirm. Still, you wonder what purpose a simulation would serve. Are you part of an ancestor experiment? A way for advanced beings to study their own past? Or maybe this is entertainment, a giant video game with you as the NPC who thinks he's real. Maybe it's training ground for cosmic teenagers learning to code. You imagine a student somewhere getting graded on whether Earth survives climate change. A chilling thought. Your struggles as homework. Historians of science still argue whether the laws of physics themselves offer clues. Some claim the universe looks quantized in ways that resemble pixelation, reality broken into minimum units, like a cosmic screen resolution. Others say that's just how physics works. No simulation required. No consensus exists, and maybe none ever will. But the speculation persists, because deep down, humans can't resist asking if there's a curtain to peek behind. Here's a quirky break. In 2016, physicists actually published a paper exploring whether cosmic rays, the high-energy particles zipping through space, show patterns that would betray a simulated grid. The study was half serious, half playful, but it sparked wild headlines. Scientists try to prove the universe is a computer. Spoiler, they didn't prove it. But the fact the question could even be posed shows how deeply the whisper has crept into science, as well as philosophy. Imagine for a moment that the whisper is true, that every star you've visited tonight, every rogue planet, every volcanic apocalypse is just code. Failed worlds aren't real, they're just failed lines in a script. The entire cosmic lottery is a set of simulations, trial runs, reboots. Earth isn't just lucky, it's curated, selected from an endless menu of attempts. The thought is dizzying, but also strangely calming. If it's all a simulation, then maybe the chaos doesn't mean failure, it just means debugging. Sarcasm smirks. Of course, that explanation doesn't make your daily frustrations any better. Stubbed toes still hurt, heartbreak still stings, and your phone battery still dies at 2%. If this is a simulation, the programmers clearly prioritize cosmic beauty over user experience. 10 out of 10 for galaxies, 0 out of 10 for traffic jams. You wonder too, what if civilizations elsewhere figured this out? Maybe they rose far enough to see the code itself, glimpsing the machinery under reality. Maybe that's why you don't hear them, because once they learned, they logged off or shut down, or were shut down. The Fermi paradox gets darker when you add simulation theory. Perhaps silence isn't absence, but censorship. Historians of philosophy still argue whether believing in the simulation changes anything. After all, even if you are data, your experience feels real. Pain hurts. Joy soothes. Stars inspire. Believing it's only a simulation doesn't make those sensations less vivid. Some thinkers argue the distinction is meaningless. If reality is simulated but consistent, it's real enough. Others insist it matters deeply. The meaning evaporates if everything is fake. The debate remains unsettled. Another whisper without closure. Here's your quirky morsel for bedtime. In 2010, Elon Musk joked that the odds we're not in a simulation are 1 in billions. The comment ricocheted across the internet, sparking memes, debates, and nervous laughter. Whether he was serious or not didn't matter. The idea struck a nerve. People half wanted it to be true, half dreaded the possibility. Because if it's true, you're both insignificant and immortal. Nothing more than code, but code that could, in theory, be copied forever. You pause, letting the whisper settle. Whether true or not, it reframes everything you've seen tonight. Failed worlds become test runs, grave markers become deleted files, rogue planets become abandoned servers drifting in cosmic storage. Earth itself becomes a level that happened to load correctly. The universe stops being random and starts being intentional, though perhaps not in the way you expected. Sarcasm offers one final aside. If this really is a simulation, then whoever programmed it deserves both praise and a complaint letter. The graphics are stunning, the physics engine is flawless, but the plot, confusing, occasionally cruel, full of filler episodes, needs work. And yet even with all its glitches, the simulation whisper soothes you. Because whether coded or not, you still breathe, still dream. And if someone or something is watching, maybe your dreams matter too. Maybe the very act of wondering proves you're not just a line of script, but a voice worth hearing. As your eyelids droop, you imagine the universe flickering like a screensaver, stars pulsing like pixels, galaxies rotating like rendered animations. You whisper to yourself, real or not, it's beautiful. And then you drift, halfway convinced the programmers have dimmed the lights for you, letting the simulation rock you gently towards sleep. You let the simulation whisper fade, drifting through imagined grids and glowing pixels, until another question bubbles up. If the universe, or simulation, or whatever stage you're floating through, is this wide and this inventive, why should life everywhere look like you? Why insist on carbon and water, cells and DNA, forests and lungs? Tonight you wonder, what if life writes itself in stranger alphabets? What if survival blooms in chemistries you've never considered? Life beyond carbon, thriving where your biology would perish in seconds? You hover first above Titan again. Saturn's orange child. Methane rains here. Methane rivers carve valleys. Methane lakes lap against icy shores. To you, it's poison. To chemistry, it's an invitation. Some scientists imagine creatures here not made of water, but of liquid methane, with membranes built from exotic molecules called azotosomes. Imagine cells that don't dissolve in gasoline seas, creatures that sip methane the way you sip water, their metabolisms ticking slowly in the cold. To them, Earth would look lethal, a furnace drenched in corrosive liquid. Your paradise, their apocalypse. Historians of science still argue whether such methane-based life is possible at all. Many biologists insist water's unique properties make it essential. Its abilities to dissolve substances, its wide temperature range, its role as a chemical medium. Others push back, pointing out that life has already surprised you countless times, thriving in acid pools, salt flats, radioactive ruins. If microbes can shrug at arsenic, why not methane? The debate remains unresolved, a tug-of-war between caution and imagination. Here's your quirky tidbit. In 2010, NASA scientists announced they had found a bacterium that could use arsenic instead of phosphorus in its DNA. The claim caused a media storm, alien life found on Earth, though follow-up studies later challenged the result. Still, the idea lingered. Maybe even on Earth, life has more flexibility than your textbooks suggest. Perhaps biology isn't one recipe but a whole menu, and you've only ordered the first dish. Now picture life made of silicon. On Earth, carbon reigns because it forms long stable chains ideal for complex molecules. But silicon sitting right below carbon on the periodic table has similar properties. Sci-fi authors love to imagine silicon life forms, crystalline beings with metabolisms based on rocks instead of organic goo. Maybe on volcanic worlds with plenty of silicates, such life could evolve. Their bones wouldn't be calcium, they'd be quartz. Their skin might sparkle with minerals. To shake their hand would feel like tapping glass. Sarcasm drifts in. Imagine the interplanetary cultural exchange. Here's a sandwich, do you say? Here's a pebble, they reply. Not exactly a shared dinner party. You move on, imagining ammonia seas. Ammonia can dissolve many compounds like water does, and in colder regions of the galaxy, it might serve as a biological solvent. Creatures here might breathe hydrogen, exhale nitrogen, and crawl through icy oceans at temperatures that would freeze your blood instantly. They'd find Earth unbearably hot, a blazing oven compared to their gentle chill. For them, room temperature might be 150 degrees below zero. Historians of science still argue whether energy sources on such worlds could drive evolution. Sunlight may be weak in the outer reaches, but chemistry can still hum along. Hydrothermal vents, radiation from stars, even geothermal heat could fuel slow, deliberate life. Evolution might move glacially, but patience is a trait the universe has in abundance. Here's your quirky break. In the 1950s, British chemist JBS Haldane mused that life could exist not only in oceans but in clouds, beings made of gas, drifting like jellyfish in atmospheres. He imagined creatures buoyed by hydrogen balloons, feeding on sunlight or chemistry. Decades later, scientists looked at Jupiter and wondered the same. Could its stormy skies host floaters, balloon-like organisms drifting in layers where temperatures are mild? It sounds like fantasy, but so did microbes that eat metal until you found them in mines. You drift back to Earth and consider extremophiles, the test cases proving biology's range. Microbes living in boiling geysers, in acidic lakes, in salt so concentrated it crystallizes around them. Some survive in radiation levels 1,000 times higher than humans can tolerate. Others hibernate for millions of years in permafrost, then wake up as if nothing happened. Life already pushes every boundary you've set. Why not imagine it stepping beyond carbon altogether? Sarcasm nudges. Meanwhile, humans panic if the thermostat shifts 2 degrees or if the Wi-Fi goes out for 10 minutes. Extremophiles shrug at boiling acid pools. Clearly, Earth's toughest residents are not the ones writing bedtime stories. You hover above an exoplanet now, its atmosphere rich in sulfur compounds. On Earth, sulfur often signals rotten eggs or choking fumes, but some microbes love it, metabolizing sulfur the way you breathe oxygen. Scale that up and maybe entire ecosystems thrive on sulfur cycles. Forests of crystalline plants might exhale sulfur dioxide, while predators lap up sulfur compounds from their prey. The air would burn your lungs, but to them it would smell like springtime. Historians of science still argue whether life needs DNA-like molecules to store information. On Earth, DNA and RNA dominate, but other molecules could, in theory, play the same role. Some chemists imagine polymers of silicon or even magnetic patterns etched into exotic minerals, carrying genetic instructions. If so, life might not even look alive to your eyes. You could walk past it, dismissing it as rock or dust, never realizing it has a memory. Here's another quirky morsel. In 1952, biochemist Stanley Miller's famous experiment created amino acids by just sparking gases thought to mimic early Earth. But when scientists repeated the experiment decades later with slightly different gases, they produced whole suites of unexpected compounds. A reminder that chemistry is generous. Given the right nudge, molecules organize themselves in ways you'd never predict. You imagine now walking on an alien shore, the sand crunching under your boots, but instead of trees, spires of crystal rise, shimmering as though alive. Instead of animals, clouds drift low, pulsing softly with light as they absorb chemicals from the air. Instead of insects, tiny metallic flakes scuttle, leaving magnetic trails in their wake. None of it carbon, none of it familiar, and yet all of it alive in its own way. You'd call it alien, but to itself it's just normal. Sarcasm chuckles. Humans struggle to recognize life even on their own planet. Sea cucumbers, slime molds, viruses. Half the time you're not even sure what counts as alive. Good luck spotting silicon jellyfish or methane puddle creatures without squinting. And yet, thinking about these possibilities soothes you. Because if life can bloom in carbon, maybe it can bloom elsewhere too. Maybe the universe is full of chemistries you'll never taste, full of creatures you'll never name, full of histories you'll never read. Earth is rare, yes, but not alone. The menu is bigger than you can imagine. Historians of science still argue whether you'll ever find such life. Some say it's inevitable, that with enough worlds, variety guarantees it. Others say carbon water life is so effective that alternatives may never arise. The truth is still hidden, folded in light years of distance. But the act of wondering stretches your imagination, softens your perspective, and reminds you that possible is a flexible word. As your eyes grow heavy, you picture an alien tide pool, methane waves lapping, crystalline creatures inching across the shore, their trails sparkling like frost. Somewhere in the galaxy, life may already be crawling, swimming, floating, breathing, not carbon, not water, not anything you'd recognize, but alive nonetheless. And the thought rocks you gently, like a lullaby hummed in a language you don't yet speak. You drift away from thoughts of alien chemistries, letting methane seas and crystalline forests fade into the dark. The universe is not just about beginnings and maybes, it is also about endings. Every world, even Earth, has a clock ticking quietly inside it. Some planets have already run out of time, others, like yours, are still in the middle chapters. But the story of endings is inevitable, and tonight you lean into it, not with fear, but with the calm of someone reading the last pages of a book by dimming the lamplight. Start with Earth's most certain fate. In about 5 billion years, the sun will swell into a red giant, its outer layers ballooning outward until they scorch Mercury and Venus. Earth's oceans will boil, its atmosphere will peel away, and the crust itself may melt into rivers of fire. Even if the planet survives physically, it will be stripped to silence. No forests, no oceans, no whispers of life. A grave marker orbiting a star too swollen to notice. Historians of science still argue about the exact timeline. Some believe Earth's biosphere has less than 1 billion years left, long before the sun becomes a giant. As the star slowly brightens with age, its extra heat will push Earth into a runaway greenhouse effect much like Venus. Oceans may evaporate, leaving behind salt flats and toxic skies. Life may vanish far earlier than 5 billion years. The debate simmers in research papers, but the conclusion is the same. Earth's story ends, whether sooner or later. Here's your quirky tidbit. In the 1970s, astronomer Carl Sagan liked to remind audiences that the sun is a main sequence star, a phrase that sounds boring but really means a middle-aged fireball that will one day eat you. He delivered the line with a smile, charming and terrifying in equal measure. A reminder that your day at the beach rests on a star slowly warming, 1 degree at a time. You float farther out and consider other endings. Rogue planets drift already in eternal night, their heat gone, their surfaces frozen solid. These are worlds whose clocks ran down early, exiled from their stars. Then there are volcanic apocalypse worlds like Io. Eventually, even their fire will cool, their plumes fade, their surfaces harden. Quiet giants will become quieter still, tectonics ceasing, cores cooling, magnetic shields failing. The end isn't just fire, sometimes it's silence. Sarcasm nudges. People worry about retirement funds, midlife crises, and dental checkups, as though those are the great threats. Meanwhile, the entire biosphere is on a countdown timer. Compared to 5 billion years, your stress over car insurance looks adorably small. Now you think bigger. Stars themselves die. The small ones, like red dwarfs, fade slowly into black dwarfs, dark embers cooling for eternity. The big ones collapse in explosions so violent they forge heavy elements and scatter them into space. Entire planetary systems are destroyed in seconds, their worlds vaporized. A supernova is the ultimate eviction notice, sudden and final. If you lived on a planet orbiting a massive star, you'd never see the ending coming. One day the sky would flash brighter than 1 billion suns, and then nothing. Historians of science still argue about how many planets survive such events. Some suggest distant worlds might endure, scarred but intact, orbiting neutron stars or black holes. Others believe the violence erases them completely. Either way, the ending is spectacular, written in fire instead of ink. Here's your quirky break. In 1992, astronomers discovered the first confirmed exoplanets, not around a normal star but around a pulsar, the corpse of a supernova. Imagine that, planets surviving their sun's death, orbiting a spinning lighthouse of radiation. They are blasted constantly, bathed in deadly rays, but still they circle. Survivors of apocalypse, holding vigil around a corpse. You drift now toward the far future, billions upon billions of years ahead. Stars burn out, galaxies collide, black holes merge. Eventually even black holes themselves evaporate through a process called Hawking radiation. In the most distant future, cosmologists can imagine the universe itself grows dark, cold and empty. No stars, no planets, no heat. Just silence stretching into infinity. The ultimate ending not in fear, but in the slow extinguishing of every light. Sarcasm leans in again. Humans argue about the end of the year, the end of a century, the end of civilization. The universe is planning a far grander finale. Total cosmic blackout. Compared to that, your deadline at work isn't exactly the apocalypse. You pause and consider, is this inevitability depressing or strangely peaceful? Perhaps both. It means even the most successful worlds end eventually. even the lucky ones, even Earth. But it also means failure isn't special, it's universal. Every world fails in the end. What matters is the middle chapters, the brief span where oceans ripple, skies breathe, and life wonders at itself. Endings are guaranteed, but beginnings are rare. Historians of science still argue whether the universe might reboot itself. Some models suggest cycles of big bangs and big crunches, infinite beginnings and endings. Others lean toward eternal expansion, where galaxies drift farther and farther apart until isolation rules. No consensus, just speculation. Endings yet to come are not fully written, only outlined in cosmic drafts. Here's your quirky note. Ancient Norse mythology described the end of the world as Ragnarok, when gods fall and the cosmos burns, only to be reborn anew. It's oddly similar to some cosmological models. Humans, it seems, have always sensed the need for cycles, death followed by renewal. Even myths whisper endings yet to come. You drift closer to Earth once more, imagining the more immediate endings, climate shifts, asteroid impacts, supervolcano eruptions. Humanity itself may face endings far sooner than the sun's red giant phase. Civilizations rise and fall in centuries, not eons. For all your species' pride, it's just another story scribbled on thin parchment, vulnerable to fire and water. But even that fragility is part of the beauty. You write knowing the ink will fade. Sarcasm sighs. Humans stockpile toilet paper during crises, convinced that's the ticket to survival. The planet has survived asteroid strikes, volcanic winters, ice ages, and extinctions. Toilet paper won't save you, but resilience might. And yet the thought of endings doesn't need to unsettle you. It can soothe. Because knowing the story has a close makes each page more precious. You savour the oceans because you know they won't last forever. You marvel at the stars because you know they'll fade. You listen to your own breath because you know one day it will stop. Fragility sharpens beauty. Endings give meaning to middles. Historians of science still argue whether intelligence changes that trajectory. Could advanced civilizations escape their endings, spreading to new stars, new galaxies, perhaps outlasting even the universe itself? Or are they doomed like everything else, their ambitions swallowed by entropy? The debate is open, but perhaps it doesn't matter tonight, because for now Earth spins, the sun burns steady, the moon glows softly. Your ending isn't yet. You close your eyes, letting images of cosmic finales blur together, stars swelling, planets cracking, black holes evaporating, galaxies dissolving. Endings yet to come stretch beyond your imagination, beyond your lifespan, beyond your species. They are distant, inevitable, immense, and yet, right now, you are here, breathing under skies still alive. The ending waits. But tonight the story continues. You linger in the quiet after thinking of all those endings, and a strange emotion rises. Not fear, not awe exactly, but a kind of absurd wonder. Against all odds, Earth has survived. Against every failed planet, every missed roll of the cosmic dice, every ending waiting in the wings, you are still here. And when you weigh the scale, the grave markers, the rogues, the toxic seas, the volcanic firestorms, it almost feels impossible. Survival itself feels absurd. Imagine a cosmic lottery with trillions of tickets, most of them blank. Some are scorched, some are frozen, some are shattered into dust. And then, by chance, Earth's number comes up. You exist not because survival was likely, but because the universe seems to allow at least a few jackpots. That realization is dizzying. You are not the default, you are the exception, and living as the exception is both beautiful and ridiculous. Historians of philosophy still argue whether this absurdity is comforting or crushing. Albert Camus wrote that the absurd arises when humans seek meaning in a universe that doesn't offer any clear answers. Some people respond with despair, others with rebellion, others with laughter. Tonight you float in the middle, realizing that maybe the absurdity is the point. Survival doesn't need to make sense to feel precious. Here's your quirky tidbit. In 1977, NASA launched the Voyager spacecraft, each carrying a golden record with sounds and images of Earth, music, greetings in dozens of languages, the sound of waves and birds. Carl Sagan famously said the record was like a bottle cast into the cosmic ocean. But think about it. Humanity made a mixtape for aliens, then flung it into interstellar space with no guarantee anyone would ever listen. It's absurd, deeply absurd, but it's also beautiful. Survival gave you the chance to sing into the void. You drift across the gallery of failed worlds again in your mind. Venus's suffocating clouds, Mars's dried riverbeds, Io's lava fountains, rogue planets wandering in silence. Each one is a reminder of how often survival fails, and yet Earth continues, oceans shimmering, forests rustling, creatures laughing and crying and singing. Against the backdrop of silence, your noise is absurdly loud. Sarcasm perks. Humans complain when the coffee shop runs out of oat milk, as if the universe has failed them personally. Meanwhile, their entire existence rests on an improbable stack of coincidences that kept Earth habitable for 4 billion years. Oat milk shortages barely register on the scale of absurd survival, but the absurdity runs deeper. Consider consciousness itself. Out of rocks, gas, and random chemistry, neurons assembled into minds capable of wondering about the universe. You, a collection of atoms, are pondering your own improbability. Rocks thinking about rocks. Chemistry asking questions about chemistry. It's not just absurd, it's hilarious. You're a punchline written into the laws of physics. Historians of science still argue why consciousness evolved at all. Was it inevitable, the natural result of complex brains, or is it a rare fluke, one more cosmic coincidence on the pile? The debate is ongoing, unresolved, like so many others. But the absurdity doesn't care about resolution. It thrives in the very fact you're asking at all. Here's another quirky morsel. In 1976, mathematician John Conway invented the game of life, a simple computer simulation where patterns of dots follow basic rules: live, die, reproduce. From those rules, complex shapes emerge, moving, shifting, evolving. People stared at their screens, mesmerized by lifelike patterns emerging from almost nothing. It was a toy, a joke, a code experiment. And yet it mirrored the absurdity of real life. Simple rules, endless complexity, survival flickering in and out. Now picture Earth itself from afar, a blue marble glowing against black space. You know how rare this is, how many failures surround it. And yet life didn't just survive, it thrived, to the point of inventing art, stories, music, love. Dinosaurs could have stayed forever. Microbes could have stopped at puddles. Instead, evolution went on until one day, apes stared at stars and wondered if they were alone. It's absurd, it's improbable, it's breathtaking. Sarcasm strolls in again. If the universe really is a simulation, then whoever coded it went all out for the comedy genre. Dinosaurs wiped out by rocks from space, humans inventing fidget spinners, octopuses evolving intelligence but staying underwater where they can't build spaceships. Survival is slapstick. And yet, the absurdity has a soft edge. It doesn't diminish survival, it highlights it. Because if existence is improbable, then every breath is a victory. Every sunrise is applause. Every silly moment from spilled coffee to falling in love is cosmic rebellion against the odds. Survival feels absurd because it is absurd. And yet, here you are, absurdly alive. Historians of science still argue whether life elsewhere faces the same absurdity. Are we alone in this ridiculous miracle, or are there countless others laughing in their own oceans, forests, or methane seas? The silence of the stars suggests rarity. But rarity doesn't mean uniqueness. Even one other absurd survival somewhere else would prove the universe has a sense of humour. Here's one last quirky note. In 1974, scientists sent the Arecibo message into space, a radio signal encoding information about Earth. It was aimed at a star cluster 25,000 light-years away. If anyone out there receives it, and if they respond, the reply won't arrive for 50,000 years. Think about that. Humans sent a message they'll never live to read. It's absurd in scale, absurd in hope, absurd in patience, and yet it's also beautiful. Survival gave them the chance to try. You let all of this wash over you, the coincidences, the near misses, the grave markers, the absurdity. It's too much to comprehend, but maybe that's the point. Survival isn't about making sense, it's about persisting long enough to notice. You are noticing. That's enough. Sarcasm offers one final wink. Someday, long after Earth is gone, long after stars fade, maybe the only surviving record of your species will be a gold record drifting through the void or a message that never got a reply. Imagine the absurdity. Billions of years of survival, distilled into Chuck Berry's Johnny B. Good flying through interstellar space. That's humanity's punchline. And yet it fits. Because survival isn't neat. It isn't logical. It isn't tidy. It's absurd, and that absurdity is why it feels so precious. As your eyes soften, you picture Earth once more, a fragile blue dot in a sea of failure. Against all odds, it spins. Against all endings, it sings. Against all silence, it whispers stories into the night. And you, absurdly lucky, absurdly alive, drift with it into sleep. Now that all the 20 sections are complete, would you like me to create the 300-word wind-down epilogue to close the script? The images of failed worlds, volcanic firestorms, rogue wanderers, and improbable survivals begin to fade as though someone is gently dimming the projector in a quiet theatre. You feel the weight of everything you've travelled through tonight. The silence of craters, the hiss of vanishing atmospheres, the improbable balance of oceans held against chance, and all of it melts into a single truth. You are here, breathing, safe, small but not insignificant. The cosmos may teem with endings, but for now your world is alive, and so are you. Your breath slows naturally as you picture the Earth not from orbit, not from history books, but from your own window, the way the night air cools a room, the way a breeze slips past the curtain, the way familiar hums of your home hold you steady. The distant violence of failed planets feels softened now, wrapped in the certain knowledge that you're sheltered for this moment. The stars above may whisper billions of stories, but you only need to hear one: rest. Your body feels heavier, not from burden but from release, as though the gravity of Earth itself has tucked you in. Shoulders slacken, jaw softens, thoughts loosen their grip. Every worry you carried today, whether vast like extinction or tiny like forgotten chores, fades into the background noise, smaller and smaller, until it vanishes altogether. You float not through space but through calm. Let yourself trust that calm. The universe has waited billions of years to give you this breath, this night, this chance to rest. Tomorrow the questions may return, but tonight the only answer is quiet. You are safe, you are drifting, you are already halfway to dreams.